Hi, good morning, everybody. My name is Matt Botil, and I am the Division Chief for the Industrial Strategies Division. And I just want to welcome you all to what is, I believe, the 9th workshop we are holding on the 2022 Scoping Plan update. So today's workshop is focused on short-lived climate pollutants, and this is a follow-on to the brief overview we gave at the kickoff workshop back in early June. So really excited to have quite a number of folks to come and speak today on the progress that the state has made towards reducing short-lived climate pollutants and what the future potentially looks like. We've got a pretty busy agenda today, so we've got plans for speakers from multiple state agencies, industry, and as well as representatives from the environmental justice community. They're going to speak. So I'm going to go ahead and just jump right into it since it's going to be a full day. So with that, I'm going to hand it off to Jeff Kessler, who is an air resources engineer in the short-lived climate pollutant policy section here in the Industrial Strategies Division. And he is going to do a brief overview and then also help kind of MC the day for us. So Jeff, go ahead and take it away.
Great, thanks so much, Matt. So if we can jump to the next slide. So this should be a pretty familiar slide for many of you, and we've been including it in all of the 2022 Scoping Plan workshop materials so far. And this is really just to remind us that we need to redefine our scope of sources and sinks in the framework of carbon neutrality. So simply put, carbon neutrality is achieved when emission sources equal the emission sinks. And for the scoping plan, our goal is to lay out a pathway for California to achieve carbon neutrality no later than 2045. And then there has been recent direction from Governor Newsom. And so in line with that, we will be evaluating pathways for carbon neutrality by 2035. The short-lived climate pollutants that are the focus of today's workshop are a source of emissions in the state. And that's similar to the sources listed on the left hand of this slide. If you want to jump to the next slide. So the scoping plan process started in late May this year with the reconvening of the Environmental Justice Advisory Committee. We've been conducting workshops, and the Environmental Justice Advisory Committee is now meeting. The short-lived climate pollutant workshop follows the June 8th kickoff presentation and the August 17th scenario concept workshop, and that material is available on our website if you've missed that. The finished scoping plan is due at the end of 2022, and we plan to have additional public meetings and materials coming out through the end of the year and into next year. Next slide, please. Just to remind everyone, we are accepting public comments, and consistent with our approach to comments from the past scoping plan workshop, we're dedicating time for members of the Environmental Justice Advisory Committee to share their comments and thoughts. During the comment period, commenters will need to unmute themselves to speak, and CARB staff will periodically announce the number of hands that are raised. Next slide, please. And so when you see this sort of slide again, it's to remind you how this process works. So the EJ Advisory Committee presentations and questions will be followed by a public question and answer period. And so that will be a 15-minute period for the EJ folks, and then it will move over to a public question and answer period. And so you will need to click the raise hand button to get in the queue. And then when you are called on by staff, you will need to click this unmute button by yourself. So staff cannot fully unmute you. The red arrow at the top of the toolbar will expand the control panel for additional options, and that's where you can see your raise hand and your unmute button. Next slide, please. As Matt said, today's workshop is focused on short-lived climate pollutants, and you'll hear us refer to this throughout the day as SLCPs. We'll be presenting material that shows our progress towards our 2030 SLCP reduction targets. We'll also provide a snapshot of where we stand today with respect to the SLCP targets. And we're looking for public feedback on the potential to further strengthen SLCP emission reduction targets and mitigation opportunities. And those kinds of guidelines need to be consistent with the 2035 or 2045 carbon neutrality targets that we're talking about. Next slide, please. As we move through the scoping plan process, we will continue to look for feedback to help inform the timing and options for achieving carbon neutrality. as we look at various target years for achieving carbon neutrality, whether it's 2035, 2045, some other year. We have several important questions, particularly around the use of captured methane. Should we use captured biogas for energy? If so, should the captured resource be directed towards transportation fuels, industrial applications, or other energy and non-energy uses? In what instances should lower cost destruction pathways take priority over energy use? How should we best utilize solid biomass waste? Does it make sense for this resource to be directed towards energy products? We think it's important to keep these questions in mind today as we hear from a variety of different presenters, and we welcome your feedback on these questions and other more specific questions throughout the day. Next slide, please. So the workshop is split into really two parts. The first part of today's workshop will be focused on methane emissions associated with oil and gas production, as well as natural gas transport through pipelines. I will then move into a brief overview of black carbon and hydrofluorocarbon emissions and what has been happening to them in terms of reductions. A representative chosen by the EJ Advisory Committee will share their perspective on emission reduction opportunities for these sectors. And then finally, we'll move to the public comment period before a short break that will then start the second part of the workshop. So next slide, please. The second part of today's workshop will be broken up into two sessions. The first session will cover methane emissions affiliated with dairy and livestock sector. This will include presentations from the Department of Food and Agriculture, CARB, and a representative of the EJ Advisory Committee and an industry representative. We will be discussing the progress made to date for reducing emissions from dairy and livestock operations and existing trends relevant for carbon neutrality target setting. The second session of the day will be dedicated to discussing methane emissions affiliated with organic waste disposal, and then also the potential for renewable natural gas as an end use. The session will consist of presentations from CalRecycle, CARB, the California Public Utilities Commission, a representative from the EJ Advisory Committee, and then also an industry representative. The RNG use portion of the session is aimed really at exploring possible uses for methane gas, and time has been allotted for each session of the workshop for the Environmental Justice Advisory Committee to discuss their perspectives and to provide any additional comments or thoughts on what has been presented. Next slide. So a quick overview on short-lived climate pollutants. What are they? SLCPs are potent climate-forcing gases with relatively short atmospheric lifetimes. That's the short-lived component of it. This includes things like methane, black carbon, and some fluorinated gases, including hydrofluorocarbons or HFCs. The science unequivocally underscores the need for immediate reductions of these short-lived climate pollutants due to their outsized impact on climate change, especially in the near term compared to longer-lived greenhouse gases. Next slide. So the legislature has recognized the immediate climate benefits that could be achieved from controlling these short-lived emissions, and they've passed SB 1383, which required CARB to adopt and begin implementing a short-lived climate pollutant strategy by January 1st of 2018. In addition to requiring CARB to adopt and implement strategy, SB 1383 requires that emissions of methane and hydrofluorocarbon gases be reduced by up to 40% below 2013 levels by 2030. And then recognizing that there's tremendous health benefits for reducing black carbon, 1383 also requires that anthropogenic black carbon be reduced by 50% below 2013 levels by 2030. CARB's SLCP reduction strategy is California's plan to reduce SLCP emissions, and that has been available on our website for quite a while now. And measures in the strategy are a key part of the state's 2017 climate change scoping plan, with SLCP measures providing over a third of the cumulative greenhouse gas reductions needed to reach the 2030 greenhouse gas target. Next slide. So the SB 1383 2030 target includes this 40% reduction in methane and hydrofluorocarbon emissions from 2013 levels by 2030, and also that 50% reduction in black carbon by 2030. These targets on this graph are represented by the green bar. And then in preparation for this workshop, CARB staff reviewed rulemaking documents, the emission inventory public reports, and other information to get a better understanding on the path the state is on for reducing SLCPs in line with that 2030 target. The results are shown in this cross-hatched bar. If we assume that technology change is similar to current rates and that the measurable effect of already implemented policies remains consistent with what we've historically seen, then all three emission categories are likely to fall short of the SB 1383 targets. So our goal with this slide is really to highlight the potential need for additional action in the sector, and this is by no means a comprehensive analysis, and modeling for the scoping plan must still be completed to get a better understanding on progress towards 2030 SLCP reduction pathways and what that means in support of carbon neutrality. Next slide. This slide shows the development of the three main areas that are needed for SLCP reductions. First off, there's a policy objective. Second, there's a set of actions that can be used to achieve that policy objective. And then third, there's mechanisms that encourage and motivate those actions. So policy objectives include things like emission reduction targets. For instance, SB 1383 established a policy objective to achieve a 40% reduction in methane from 2013 levels by 2030. Additionally, there are a set of actions or on-the-ground activities that may be used to help achieve that policy objective. That includes things like organic waste diversion. And finally, the mechanisms for driving those actions that achieve a policy objective. This can include incentives or policies like a low carbon fuel standard or a clean product standard. CARB is looking for public comment to better understand what might be done to further enhance emission reductions that relate to SLCPs and what targets might be reasonable to set through 2035, 2045 that are consistent with carbon neutrality goals. Next slide. For this stage of the scoping plan process, CARB is primarily trying to understand the policy objectives. So those are things like targets that should be established for all SLCPs in support of carbon neutrality by 2035 or 2045. And in this workshop, we will really be highlighting some of the actions that are currently being taken, and we hope to understand what additional on-the-ground actions should be pursued in support of future policy objectives. Next slide, please. Given the nature of SLCP emissions, it's important to remember that the policy objectives and the actions taken to meet those policy objectives can also impact emission reduction pathways across other sectors. So we want a set of policies and actions that put us on a path towards carbon neutrality for the state as a whole, not just policies or actions that are beneficial for one sector at the expense of another sector. So this slide shows just one example. For instance, if we capture and redirect biomethane to specific end uses like transportation or electricity, the energy demands and greenhouse gas emissions of those sectors and others also change. These SLCP connections raise many questions around emission reduction potential, technology availability, costs, air quality, and public health, among other concerns. And we welcome your input and look forward to evaluating this as a part of the scoping plan process. Next slide, please. So next up, I'll hand this over to one of our presenters to present on individual short-lived climate pollutant sectors. First, we'll hear from Lucy Cheadle from the Oil and Gas and Greenhouse Gas Mitigation Branch at CARB. And so with that, Lucy, do you want to take over?
Great, thanks so much, Jeff. So first, just a quick overview on methane emissions in California. Total methane emissions in California in 2013 were 41 million metric tons of CO2e based on a 100-year global warming potential, and methane emissions account for 9% of the state's annual greenhouse gas inventory. Major sources of methane in California include dairy and livestock, landfills, and oil and gas. Next slide, please. Fugitive methane emissions from the oil and gas sector are the third largest source of methane emissions in California, making up approximately 6 million metric tons CO2e of statewide emissions per year. Almost 3/4 of the fugitive methane emissions from this sector come from natural gas leaks that occur over the 200,000 plus miles of natural gas transmission and distribution pipelines and equipment. Next slide. In March 2017, the board adopted the Oil and Gas Methane Regulation to help address fugitive methane from oil and gas facilities. This regulation builds off of existing local air district rules targeted at reducing VOCs and includes additional areas and equipment not covered by local programs. The regulation went into effect January 2018 and includes requirements for quarterly leak detection and repair surveys to ensure that any leaking components are identified and the emissions are mitigated. Over the past 3 years, CARB and the local air districts have been working together to implement the regulation and reduce methane. In June 2017, the California Public Utilities Commission, or CPUC, in consultation with CARB, approved a decision which requires gas corporations to implement 26 best practices for methane leak detection, quantification, and mitigation in order to reduce methane emissions from commission-regulated facilities. The CPUC instituted the Natural Gas Leak Abatement Program to ensure that utilities are implementing the best practices. Next slide. This figure shows the various segments of the oil and gas sector. CARB's oil and gas methane regulation covers oil and gas production facilities, in addition to natural gas gathering and boosting stations, processing plants, transmission compressor stations, and underground storage facilities. The CPUC's Natural Gas Leak Abatement Program covers natural gas transmission, underground storage, and distribution facilities, including transmission and distribution pipelines. Next slide, please. The 2017 SLCP reduction strategy that Jeff mentioned established fugitive methane emission reduction targets specific to the oil and gas sector. The goals are to reduce emissions by 40% by 2025 and 45% by 2030. Next slide. The oil and gas methane regulation is anticipated to achieve approximately a 36% reduction in production and processing fugitive methane emissions by 2025, but that is short of the SLCP target of 40% reduction. For the Natural Gas Leak Abatement Program, the gas utilities appear to be making progress towards the emission reduction targets, but the CPUC, in consultation with CARB, is currently evaluating the reductions and working with utilities to improve leak measurement methods and emission reduction strategies. With the current oil and gas methane regulation, we may not be on track to achieve our SLCP reduction strategy targets, but there are steps we can take today to further reduce emissions from the sector, and strategies to reduce methane from oil and gas facilities are typically very cost-effective. We're proving here in California that significant reductions in oil and gas methane can be achieved using cost-effective strategies, and as implementation of these programs continues, we will continue to look for new strategies to further reduce methane emissions from the sector. Next slide, please. As you probably know, we have solicited feedback from both the EJ Advisory Committee and public in previous workshops on designing scenarios for the scoping plan. Once we have that input, we will work with our contractors to model various carbon neutrality scenarios and assess what future fugitive methane emissions from oil and gas infrastructure might be. Some of the considerations that affect the future modeling work include the governor's directive to phase out in-state oil and gas production by 2045 or sooner, the degree to which natural gas supply and demand changes from fuel switching activities, and the extent to which renewable natural gas is included in the scenarios and how RNG is transported. Next slide, please. We welcome feedback and recommendations on how to further mitigate oil and gas methane emissions and how the sector's infrastructure might be utilized on our path to carbon neutrality. Specifically, we would like to know what additional strategies should we prioritize now to achieve greater reductions in fugitive methane from the sector. Also, as the volume of fossil gas in the state's infrastructure decreases due to fuel switching and decreased production, should the existing infrastructure be repurposed? And then how can we ensure that fugitive emissions from any repurposed infrastructure are mitigated? Any additional comments or recommendations you have regarding the oil and gas sector are also welcome. Thank you all for your participation today, and I'll now pass it back to Jeff for the next slide.
Awesome. Thanks for that, Lucy. So I'll be covering black carbon and some of the details on what has been going on in the state and where we stand on black carbon emissions right now. Next slide, please. So for those that don't know or just need a little bit of background on this, black carbon is a pretty powerful warming agent, which has a warming effect that is roughly 900 times more powerful than CO2, at least on a 100-year basis. And Senate Bill 1383 sets a specific target to reduce anthropogenic black carbon emissions by 50% by 2030. So anthropogenic black carbon emissions are really only the set of emissions that occur due to direct human-driven activities. This portion of emissions does not actually include things like black carbon affiliated with wildfires or prescribed burning. Also, it's important to note that black carbon is not an AB32 gas and is therefore tracked outside of our AB32 inventory. Next slide, please. In 2017, the black carbon emissions were estimated to be approximately 8 million metric tons of CO2 equivalents, and the majority of anthropogenic sources comes from transportation, specifically heavy-duty vehicles. Additionally, residential, commercial, and industrial applications contribute pretty significantly to overall black carbon emissions, and the share of black carbon from transportation is dropping rapidly and is expected to continue to do so between now and 2030 as a direct result of our air quality programs. The remaining black carbon emissions will come largely from wood stoves and fireplaces, off-road applications, and industrial and commercial combustion activities. And it's also super important to note that approximately 95% of the residential black carbon emissions are due to wood combustion. Next slide, please. Black carbon is a component of particulate matter, and so many of the state's efforts to reduce air quality and to improve air quality and reduce particulate matter also reduce black carbon. CARB has employed a variety of strategies that have drastically reduced particulate matter and black carbon emissions from mobile sources, including lower emission standards, clean fuel requirements, in-use rules, incentives, and investments in research and new technologies. Measures have also been implemented on the state and local levels that directly reduce particulate matter and black carbon emissions from non-mobile sources. This includes programs to reduce emissions from agricultural burning and to reduce residential wood smoke. For transportation, we continue to lead on reducing diesel black carbon emissions. There's cleaner truck and bus rules that have been established. There's a sustainable freight strategy, which will move California to a near zero emission freight transport system by 2050. Off-road and construction equipment is being addressed, and updates to the state implementation plan to achieve federal air quality standards have also all helped to reduce black carbon in transportation. In terms of agriculture smoke management, strategies have occurred, and state and local air district smoke management programs are significantly reducing the impact of agricultural burning. There's mandatory and voluntary rules that have been adopted by large air districts to restrict wood burning in residential fireplaces and heaters. Local air districts are also regulating emissions from commercial cooking operations. And finally, although natural carbon sources are not necessarily included within the anthropogenic category of black carbon emissions, there is a forest carbon plan that we anticipate will have some impacts on black carbon. Next slide, please. Significant progress has been made since 2013 to reduce anthropogenic black carbon emissions. Most emission reductions to date have come from decreased combustion of distillate fuels and fuels used in the agricultural sector, as well as improvements to provide cleaner on-road combustion technologies. Continued electrification in this area will also further help to reduce black carbon emissions across most sectors. Despite all of this, CARB's review of the current set of programs indicates that 2030 anthropogenic black carbon emissions may be slightly higher than the 2030 SB 1383 target, given the relationship between particulate matter and black carbon and the diversity of emission sources and mitigation programs. Understanding future emissions in the sector can be challenging, and so we look forward to refining these estimates in the future, and we welcome public comment on any of these things. Next slide, please. As part of future work, we have some additional analytical work ahead of us. This includes updating our anthropogenic black carbon inventory, reviewing the future scoping plan scenarios to understand the effect that various scenarios might have on black carbon emissions. And we also need to better understand the effect that current and future residential wood smoke reduction programs will have on emissions. We welcome your feedback on this and additional questions. Next slide, please. So we'll now transition to the hydrofluorocarbon part of our discussion. And so I'm going to hand this over to Glenn to take over.
Thank you. Now we are on the hydrofluorocarbons, or HFC section for short. Next slide. Hydrofluorocarbons are substitutes to ozone-depleting substances such as Freon-type refrigerants, and they're most commonly used for cooling and insulating houses and vehicles, keeping food cold and safe, and as propellants for medical and other devices. The HFC use is growing as the need for cooling increases. Although HFCs are not ozone depleting, they are powerful, short-lived climate pollutants with very high global warming potential values, or GWPs. For example, just 1 pound of the most common air conditioning refrigerant that's leaked to the atmosphere can cause the same amount of warming as 2,088 pounds of carbon dioxide, which is equivalent to burning 100 gallons of gasoline and driving more than halfway across the country. California's legislature recognized the importance of reducing HFC emissions and enacted SB 1383, requiring California to reduce HFC emissions 40% below 2013 levels by 2030. Next slide. These 2 pie charts show the sources of HFC emissions. The one on the left is for 2019, the one on the right is for 2030. Refrigerants do make up 90% of all HFC emissions, and they're almost evenly divided into refrigeration, air conditioning and heat pumps, and mobile AC. HFCs make up about 5% of all greenhouse gas emissions in California. By 2030, on the right-hand side, due to CARB existing measures and a national HFC phase down, which I will discuss later, we expect these emissions to decrease. Next slide. California has adopted several measures to reduce HFC emissions. Regulations initially adopted under AB 32 include the Refrigerant Management Program, or RMP, which requires facilities to register and report annual refrigerant usage and to repair refrigerant leaks promptly. The annual reports add to the largest refrigerant use database in the nation. For motor vehicle AC, the Advanced Clean Cars Low GWP, Global Warming Potential AC, starting in California, is now a national program. And there's also a small refrigerant can recycling program for motor vehicle DIYers, do-it-yourselfers. The consumer product aerosol propellants have HFC prohibitions, and for semiconductor manufacturing, there is an F-gas or fluorinated gas reduction program. California SNAP measures were state requirements to prevent a rollback of existing regulations at the federal level, and they prohibit high global warming potential refrigerants in several applications. And SNAP was just short for the US EPA program that was rolled back, a significant new alternatives policy, which is a ODS and HFC management program. In 2020, CARB adopted GWP prohibitions for new refrigeration and air conditioning equipment. Starting January 1st, 2022, all new facilities with refrigeration systems containing more than 50 pounds of refrigerant will be required to use refrigerants with a global warming potential of less than 150. Additionally, there are company-wide reduction targets for national chains of retail food stores. CARB has placed a 750 GWP limit on all new air conditioners and space conditioning heat pumps with effective dates of 2023, 2025, or 2026, depending upon the type of AC system. CARB also introduced a new first of its kind refrigerant reclaim and reuse requirement known as the R4 program, which applies to AC manufacturers. This will enable a more resource efficient circular economy. Next slide. At the national level, the US Congress passed the American Innovation in Manufacturing Act, or the AIM Act, last year, which includes a phase down in the production and import of HFCs. This graph shows the schedule beginning at 100% of baseline. The allocation quota of production and import is steadily reduced in a series of steps when the final 15% allocation cap begins 2036 and is frozen there indefinitely at 15%. Additionally, the AIM Act directs the EPA to address HFCs via refrigerant management in existing systems and facilitates the transition to next generation technologies. Next slide. This graph shows the progress to meet the state's 2030 HFC target. Business as usual emissions, if there were no HFC measures, are shown on the top red line, and you see they increase steadily. However, the current regulations in place will decrease the emissions. The reductions from the CARB regulations are shown in the red striped bars. We also expect additional HFC reductions from the federal AIM Act national HFC phase down. These are shown in the blue hatched portion of the bar chart. The estimated emissions are shown in the green bars. Note that even with all state and national measures in place, we still need additional reductions to achieve the 2030 HFC reductions goal, which is indicated by the dark green bar on the right-hand side. We're not quite there with current regulations. Next slide. Some of the unique challenges of reducing HFCs is that there are refrigeration and air conditioning systems in millions of households and businesses, and they contain millions of pounds of refrigerant in the existing equipment. This refrigerant is also called an installed base, or the banks of HFCs, which can be emitted over the lifetime of the equipment, generally about 10 to 20 years. There are limited or no drop-in replacements for most refrigerants in use today. This means even if all HFC production were banned today, the existing equipment would continue to emit HFCs for decades. Next slide. In this graph, we see the magnitude of the installed base, or the banks, of potential HFC emissions in the middle bar. It's compared to the annual emissions on the left. And on the right, it is compared to all the annual greenhouse gas emissions in California for one whole year in 2019. Now you can see the potential emissions are much greater than annual emissions, and the installed base is equal to 60% of annual statewide greenhouse gas emissions. So that's a lot of HFCs in equipment that we have to manage. Next slide. Reducing HFCs is also critical for achieving carbon neutrality. Studies indicate that by 2045, HFCs could be among the largest remaining greenhouse gas sources, making up much more than 5% of all the remaining greenhouse gases. And these HFC reductions are integral for achieving states' long-term climate goals. Next slide. The HFC emissions are impacted by building electrification as fossil gas-powered appliances are replaced by refrigerant-containing heat pump technologies. And although they're heat pumps, the refrigerant acts as a heat transfer fluid, so it can bring warm fluid to a place as well as cool fluid. Switching from fossil gas to clean electric heat pump technologies holds many benefits for better environmental and public health, and results in significant greenhouse gas reductions. However, most heat pump technologies today use HFCs, and as millions of refrigerant-containing heat pumps are adopted for space conditioning, water heating, clothes drying, and heating pools and spas, some of those GHG benefits will be offset by an increase in HFC emissions. Next slide. As we discussed, reducing HFCs is critical for California's short-term and long-term climate goals. We may need to use all policy instruments at our disposal to influence behavior and shift the market towards very low global warming potential alternatives. The path to a low or no GWP future may need both regulatory and incentive approaches. Regulations are integral to increasing the adoption of low or no GWP technologies. Some measures we are considering or may include green GWP limits for new heat pump sources and tightening GWP limits for the existing sources. There's a need to address the banks of HFCs through improving the recovery, recycling, and reclamation of existing high GWP refrigerants. Regarding incentives, there are many technologies that use low or no GWP refrigerants. However, there are barriers to their adoption, such as higher upfront cost and the need for updated safety standards and building codes. CARB is partnering with other agencies and utilities to provide incentives for technologies that holistically reduce GHG emissions. As much as possible, building electrification efforts should prioritize low GWP refrigerants as the heat transfer fluid. Financial incentives should prioritize low-income and disadvantaged communities. Low GWP space conditioning units can protect vulnerable communities from heat stress and wildfire smoke. Next slide. The incentives are critical for meeting the climate goals of the state as identified in the CARB's 2017 SLCP strategy. SB 1013 established the first statewide incentive program for low GWP refrigerant technologies to be administered by CARB. CARB received $1 million in the 2019-2020 budget and launched an incentive program last year focused on reducing emissions from supermarkets with an emphasis on stores located in low-income and disadvantaged communities. The draft investment plan for the cap and trade auction proceeds, which is not final, also identifies HFC reduction as an investment priority. Going forward, interagency coordination is needed for building electrification incentives to ensure the adoption of low GWP heat pump technologies and avoid locking in equipment with high GWP refrigerants that can emit for decades. Next slide. HFCs span the jurisdiction of many agencies, not just CARB. At CARB, we're making a dedicated effort to coordinate with our sister agencies as well as utilities. SB 1013 recognized the value of increasing coordination of HFC management and directed the California Energy Commission, the California Public Utilities Commission, and the Department of Community Services and Development to incorporate low global warming potential refrigerants in existing programs. We've worked closely with the Energy Commission on their efforts to reduce building emissions as directed by AB 3232 and considered the impact of refrigerants in the 2022 building codes. We're coordinating with both the CEC and the CPUC on SB 1477, which promotes clean space and water heating technologies. The Public Utilities Commission is working with investor-owned utilities to incorporate refrigerants in their energy efficiency program portfolios. CARB's also been coordinating with the State Fire Marshal's Office to provide support on the adoption of building code updates to allow the use of alternative lower GWP refrigerants. And lastly, CARB's collaborated with utilities such as SMUD, SoCal Edison, and LA Department of Water and Power on our F-gas reduction incentive program. Next slide. And to close, here are some key questions that we would like stakeholder input on. What additional strategies could be used to further reduce HFC emissions? How should we address the existing banks of the HFC potential emissions? How should we preserve the building electrification benefits with respect to HFC refrigerants? We look forward to working with all of the stakeholders to reduce HFC emissions. Thank you. This concludes the HFC part of the presentation.
Awesome. Thank you, Glenn. So our final speaker for this subset of the workshop is going to be Kevin Hamilton of the Central California Asthma Collaborative. And after we hear from Kevin, we'll move on to the public comment phase of this part of the workshop. So Kevin, if you want to unmute yourself, and you're good to go.
Great, thank you, Jeff, and good morning. As Jeff mentioned, I'm Kevin Hamilton. I'm co-director of Central California Asthma Collaborative and a member of the Environmental Justice Advisory Committee, working on the 2030 scoping plan revision. I'm also a registered respiratory therapist. I want to sort of take these from top to bottom, and let's go ahead and start with Glenn and the last presentation on HFCs. Funny thing, my brother Darryl, who was a truck driver and then a diesel mechanic, smoked Marlboro cigarettes. And back in 2001, he used to collect these little points that they had. And one of the things they offered as a prize was this cooler. And they claimed this cooler could be plugged into your car, what we used to call the cigarette lighter. Everybody else just calls it 12-volt power now. So you got one of those, and it came to the house here, and I kind of laughed at it. And it turned out it worked on thermoelectric properties. There was no Freon in the thing, no HFCs. And, you know, I plugged it in, and after about an hour, it worked great. And in fact, we took it up to the mountains, and you know what? It's still in my garage, and it still goes camping with us today. So just as an example of a technology that's been around a long time, at least for refrigeration, works. It's highly intensive as far as energy, electricity. Yet now today we have really wonderful and very cheap sources of electricity in our solar fields and wind. Now, of course, that cost savings isn't being passed on to customers, at least in a way that is noticeable to me in my PG&E bill, and certainly in the disadvantaged communities across California and the country who are vulnerable to these increased costs. We're not seeing that passed along there. But that's just one of the examples of technology that's been around for a long time, that it would seem to me that we would want to be investing in and see if we can make that more efficient. And are there opportunities for using that in things like TRUs rather than mounting a refrigeration or an HFC refrigeration unit on it? Could we line it with these electrostatic cells or whatever? I never took the thing apart to see what it looks like inside, and make that work, especially since the industry is looking at putting solar panels on top of the trailers, especially with TRUs and the cabs. So again, I think we have to think outside the box here and really look at these alternative solutions, and with a sense of urgency. I honestly don't feel that so much these days. Seems like we've kind of locked into this ennui of, well, we have these targets, we have to do it. You know, we're not going to meet these targets. I'm not accusing any one person or staff or anybody else. It's just the feeling I get when I look at it. The other thing that's been around for a long time that I remember, the original refrigerators, as some people don't know, were actually run with ammonia and heated by natural gas pilot lights in the back. These refrigerators worked very well. They were all over the country. They were everything. Now, ammonia itself in that form is dangerous. So, you know, that created a problem. And in fact, an air conditioning unit was created around that by a company in Southern California called Arclis-Savel. Now, it did require heat. And again, it was using natural gas burner to create that heat. But they have electricity today create heat. So again, I'm not suggesting that that's the greatest thing since sliced bread when it comes to this, but it does seem like there's an opportunity there that in fact we could explore, and in fact ammonia is still used as a very high level, very cold environment refrigerant. So, you know, I think those are just two things that have been out there for a long time that I don't see in this presentation, and I don't understand and see clearly where those and what are the other new technologies. There was a sort of a casual reference to post 2045 new technologies, and it would be good in the future if any presentation could include an example of some of those new technologies that are not carbon intensive like HFCs. You know, the biggest fear that I have in this is every time a new refrigerant comes along, it costs more, right? And that cost is passed along to consumers. And who are those consumers? Well, I'm one of them, obviously. I live in the valley. I kind of live and die by air conditioning in my car. And in fact, the ability to refrigerate food is what allows us to be a constructed society today. So we won't be dumping our refrigerated food anytime soon. That would be a bad idea unless somebody comes up with a more magical way to preserve all that food as it's transported around or sits in my house for 2 weeks before I end up using it. But the people who are most vulnerable here again are in our disadvantaged communities. The cost of this stuff, if something goes wrong with something they own that needs refrigerant, like a car, most of them don't get it fixed. It's just too expensive. They can't afford that $100 and some for 6 ounces or $200 for 6 ounces of the HFC they need to fix it. So, you know, how do we solve that problem? Whatever solution we come up with, you know, we're still leaving those folks out of this conversation and the solution beyond their reach. So I appreciate that it was mentioned in the discussion, but it needs to be more than mentioned. It needs to be built into a solution. And as far as incentives, I agree, we need to throw them at these industries to develop these technologies, but there needs to be a little backfilling on these incentives so that folks who need these things still and are stuck using what we have are not unfairly loaded with this cost in a way that they're vulnerable to and have no say so about and certainly can't afford. So I'll leave HFCs from there, and I'll go ahead and move on and kind of skip one and move to fugitive methane. I had to take everything here, guys, sorry. And Lucy, thank you for your presentation there. I had a couple of issues that I really want to address. And the first one that jumps out immediately is, while we tend to focus a lot, and I'm as guilty as anyone, on oil and gas production and reducing fugitive methane from there, because there's other things going on related to oil and gas production that aren't just methane related. But the pipeline is obviously your biggest target, and it's a leaky sieve, obviously, just as obviously, at least looking at this graph. So, you know, here we are looking at putting, and later today you'll hear about renewable natural gas. So we're going to put another new product into this pipeline that's already leaking. And we're going to assume that by, you know, creating new access to it, that we don't create more leaks, and this new product doesn't enhance the existing leakability of this pipeline. And that's renewable natural gases and all from all its various sources. But the thing I'm really concerned about, and that I don't see in this graph, and please correct me if I'm wrong, is the leaking from orphan well emissions. All over Kern County, we have orphaned wells. These wells have been shown by FLIR camera evaluation to be leaking regularly. There's a number of them that this has been documented. That documentation's been submitted to CARB. Two of the most egregious ones are sitting literally next to low-income apartment buildings or homes, and where children are living, and these folks are very vulnerable to this emission source. So I don't see that in this graphic. So Lucy, can you tell me, are those emissions taken into account here somewhere? Sorry to put you on the spot, but if you could answer that question, I'd sure appreciate it. Is Lucy still here?
Yes, I am. Sorry, just getting
I
my
thought maybe I was
webpage.
presenting Stephanie with a really difficult technical.
No, yeah, no, thanks for that question, Kevin. And one of the issues with orphan wells is that the emissions really aren't very well quantified, and that's actually one of the things that we're looking into, and we're working on doing a study to try and better quantify those, so we have a better sense of the scope of the problem, and with both orphan wells and also, you know, wells that have been improperly abandoned. So that's something we're looking into, and I think it's an issue nationwide that we're seeing at the federal level as well, that folks are really trying to understand what is the magnitude of these emissions, and then how do we mitigate them.
So we're working with Lawrence CCAC, as a California Asthma Collaborative, and our partner CCEJN, Central California Environmental Justice Network. We're working with Lawrence Berkeley National Lab on the summation project, you know, in Kern County, and we brought you guys into that. Probably not as much as we should have, but you know, LBNL has been doing fixed wing overflights. We have a lot of mapping of some of these orphan wells and their sites and the emission frequency. And you know, UC Riverside is published on this already. There's several publications that have already been peer reviewed on that. I think, you know, we need to work more closely on that particular issue, especially in Kern County, so we can better identify these sources and their leakage rates. And I just saw a whole bunch of brand new data that LBNL has just collected from their latest flybys. So, and of course, there's a task satellite that's also examining this area for the same project. So please email me afterward and the team, and let's talk more about that.
Yeah, that sounds great. Thank you so
again,
much.
I just feel like, I'm sorry, go ahead.
Oh, I was just going to say thank you. And yeah, we look forward to connecting more on that offline.
You're welcome. I didn't mean to be rude. I just feel a sense of time climbing on me here. That's all. That's normal for me every day, by the way, when you get old. So again, I just feel we're looking at these graphs. I've been looking at these same tables for quite a few years now, and I'm not seeing a lot of change. And so, we knew that we weren't going to hit the targets on this one probably 3 or 4 years ago. So when we did the original 2030 scoping plan, it seemed obvious to a lot of us at that point. We've got to get a little more intense about this whole thing, folks. We're really serious about doing this. So moving on to black carbon, one of my personal favorite subjects, because of the toxicity of this particular particle, especially when it's produced by an engine. So the communities that we serve and one that I live in right here, as a matter of fact, in Fresno, are adjacent to a number of distribution centers and warehouses. And these are the location also, of course, of really high concentrations of diesel trucks. And so, we need these trucks, make no mistake about it. I always laugh and tell people, my colleagues, everything in the room I'm sitting in right now pretty much came here on a truck, unless I grew it in the backyard, and I'm not growing any desks lately. So everything in my office, everything came here on a truck. The food that I eat, for the most part, came here on a truck. So how do we clean that industry up? Well, we're moving forward with several programs at CARB, but I'll be honest with you, it doesn't feel like we're moving forward quickly enough. It's a constant battle each and every time to move targets in the industry, even when industry is at the table saying, yeah, we could do that. It's been very difficult. So we need to, again, feel that sense of urgency from the agency as well, not just this agency, but all the agencies involved and the governor's office. Once again, we see off-road mobile is still, one of the highest offenders here. Off-road mobile and rules related to that have been in the offing for, it seems like 20 years now that I've been in this business, and it seems like we never quite get there. And, again, this is the places where things are building. This is, the places where people are living that are most vulnerable to these emissions. This is the equipment that's on these distribution centers and warehouses. And sometimes there's an argument over who's regulating it, whether it's the local air districts because it resides on a stationary source and doesn't leave that source, or is it CARB, or is it actually an area source? So, these sort of disagreements between the agencies and that sometimes end up leaving weak or no regulations have got to stop. Residential wood combustion, I think the state's probably addressing that one better than just about any of them I've seen. The air districts up north, down south, and even ours are coming up with innovative rules and incentives that seem to be, from my perspective at least, moving communities in the right direction and reducing this source, though I'm not seeing that so much reflected in the present pie chart. We feel strongly that, again, with on-road diesel, all these things share the same thing. They're all combustion of organic material. And I think that this conversation's getting literally snowed under, black snow, of course, by wildfire. And rightfully so. Wildfire is producing organic black carbon. It's a nasty guy, not as nasty as this stuff from these engines, but still genuinely, a nasty player when it comes to your lungs. And it's going to be with us for a while. We know that. So we need to move forward in that arena and protect our communities in different ways by creating safe spaces in their homes. But what we really want to know is what's going on. Where is the black carbon? So while goods movement is our largest concern, my organization, in partnership with CARB and UC Berkeley, well, CARB funded us. I don't know that we aren't actually working with CARB on this, but with folks at UC Berkeley, Berkeley Air, and with the communities in South Modesto, did an initial black carbon monitoring project where 2 cycles of 6 weeks each, we located these monitors in places where the community wanted to see them in South Modesto, around their schools, around their churches, adjacent to their homes, along with co-located purple air monitors. The sites were all selected by a local community steering committee we developed there outside the 617 process, but as part of it. And so the formal process, we are doing an informal process with them. And we're hoping to learn from the Air District and others, you know, what kinds of tools in that area they can bring to the table, and learn from their black carbon monitoring projects in South Fresno at about a half dozen locations, because we want to see, you know, where's the black carbon coming from? Is it these local diesel sources? Are they primary? How does that work when there's wildfire black carbon? There's so much we don't know here that we need to understand, because we need to know what kind of exposures, health exposures, people are experiencing. And without good information about what kind of exposures they're experiencing, it's hard to develop strategies to mitigate that. So we hope to do more of that in the future. We'll be working with the agency to do that, and I think this kind of testing is an important test of what is largely anecdotal evidence that industrial areas with large distributions result in this elevated black carbon. We kind of think it's so. I don't have access to data that proves it. So we're on the pathway of always data to inform our approach in this environmental justice work. And when we go looking for it in this particular arena, we just don't find a lot. So, you know, it would be interesting, and I'd have to make a lot of apologies if I was to put up more of these monitors and find out that a lot of these distribution centers are really not the bad actors for black carbon that we think they are. But until these monitors go up, it's the same conversation as in dairies, by the way. If we can't monitor it, we can't prove that it's good or that it's bad. So is it a problem? Not a problem. Can't tell you. Haven't been able to monitor and collect actual data. So in regard to stationary black carbon sources in the San Joaquin, though, by far the largest is the Chevron oil field north of Bakersfield. And it's mainly from the engines out in the middle of the fields, not from the refineries. So again, sources that related to oil and gas, certainly sitting there in with the methane. Folks, we need to be thinking more about this as systems, right? We pulled out the HFCs, we pulled out the black carbon, we pulled out the methane, but in fact, they're all coming as part of a system. So if we don't address the system as a whole and reduce the emissions as a whole from the system and help the system adjust its technology, because one affects the others, we're never going to get a solution. And most of these systems are located directly adjacent to the most vulnerable people in our state. And it's the same way across the country and around the world. So, you know, how do we change that paradigm? And more importantly, how do we protect those folks? So we got a lot to work to do here, and we're definitely up for it and want to move forward with it. But I want to thank again, Jeff, for your presentation there on black carbon. It was very interesting. It certainly illustrates the problem. Again, what I see here is, you know, a lack of solutions that I can measure from a baseline to make sure that this is real. So I'm hoping to see better data in the future on this as we move forward. So I want to thank you for your time this morning and your willingness to hear the Environmental Justice Advisory Committee's position on these issues. Thank you.
Awesome. Thank you so much for your presentation, Kevin. And so if we move to the next slide, we'll start the beginning of a public comment period. So to ask a question or make comments, please use the raise hand function in the GoToWebinar toolbar. It should be located on the right of your screen as shown in the slide. When staff calls on your name, please unmute yourself. You will need to click that little microphone button to unmute yourself. And then the red arrow at the top will expand the control panel. We're going to provide up to 15 minutes for the EJ Advisory Committee to have comments. And after that 15-minute dedicated period, we will transition to a public comment period. So that means at about 10:15, we'll be transitioning to the full public comment period. And if you do not get your questions answered during this comment period verbally, we do invite written feedback, and that is available on the workshop website. So Trish, I believe you have been monitoring any EJ Advisory Committee members that might have their hand raised. And so if you want to start allowing them time to talk.
Thanks, Jeff. This is Trish. I actually don't currently see members of the Environmental Justice Advisory Committee with hands raised. I'm talking intentionally slowly to give folks a chance because I do see committee members in attendance. Okay, we do have a hand here from Luis Olmedo. So Luis, I have unmuted you. You should be able to unmute yourself and begin your comment. Make sure that you can, there we go.
Okay. Yes, hi, good morning. This is Luis Olmedo, Executive Director of Comité Cívico del Valle. I just wanted to let the presenters know and my partner here, Kevin, colleague on the EJAC, to thank all of you for presenting the work that's been done thus far and good presentation here from Kevin. So appreciate all of that. It's a lot. It's a lot to consider. And the only thing I just want to just say is that I hope that staff here is open to providing ongoing support and these types of workshops. I can't even imagine how someone who's just trying to make ends meet, have a roof over their head and put food on the table and try to avoid homelessness in these very difficult times, that they would have time to even engage and participate in something like this. And same goes for environmental justice organizations that sit on the EJAC. We don't have nearly the amount of resources, experts, and staff that an Air Resources Board would have, and all others involved in this process. So with that said, I just hope that you continue to keep in mind that put as many of these workshops as possible together, engage this public as much, and continue to provide this type of engagement. I'm not sure if a webinar is the best format. It's not as easy, as friendly as perhaps a Zoom, but that's all I have at this point. I got a lot of questions, but I think be more productive to do it through the EJAC or through ongoing engagement with CARB. Thank you to all those who put this together.
I appreciate your comments, Luis, and this is Matt Patel from ISD. So yeah, really looking forward to potential additional opportunities and hopefully at some point in the future doing things around community meetings in person. Hopefully we can all get there at some point. Certainly, appreciate those in-person interactions and gives us an opportunity to also share additional information related to the slides. For folks that may not be aware, what we are doing as part of these workshops, we are posting the presentations, so those are available on our website for folks to review it when it's convenient. We're also recording the workshops, and so that information will be up there. And we look forward to, for Luis and others, having further conversations on shoreline climate pollutants as part of the Environmental Justice Advisory Committee meetings. And then, like I said, hopefully some in-person community meetings at some point in the future if we can get through this pandemic.
And I want one of those coolers, Kevin. I hope I don't have to pick up smoking.
You're a long way off from that, brother. I have no idea.
Thank you. We do have an additional member, Catherine Grupa-White. I have unmuted your microphone. You should be able to unmute yourself and begin your comment.
Thank you, Trish, and good morning, everyone. This is Dr. Catherine Garupa-White, Executive Director of the Central Valley Air Quality Coalition and member of the Environmental Justice Advisory Committee. Thank you to my colleagues, Kevin Hamilton and Luis Olmedo, for the comments that they already offered. Just want to highlight and underscore a few points. Really appreciate the presentations and the staff time that went into organizing the workshop today. For me, it's always difficult to enter into these conversations in our present state of the world without acknowledging that we are experiencing an ongoing pandemic and pollution from wildfires that is particularly causing harm and damage to our already overburdened environmental justice communities. And so I think it's important that we keep that context in the forefront of our minds when we're going through these planning processes. I also wanted to underscore Kevin's statements about needing a systems-based approach in the San Joaquin Valley when it comes to strategies like industrialized biomass plants and dairy digesters creating biogas to generate fuels and energy. What we see is really a siloed and piecemeal approach that, again, exacerbates conditions in environmental justice communities. I'm a little bit unclear, to be honest, from the initial overview on the flow of the agenda, because I think that there are still going to be specific presentations on those topics. So I do have comments specific to biomass and biogas, but in the interest of making space for public comments, we'll reserve those comments for later on in the agenda when we get more into depth about those specific subjects. Just wanted to also appreciate the presenters and encourage, as Luis was speaking, more opportunities for robust public engagement, and just however and whenever possible, especially when speaking, a bit of a slower pace. We're going through a lot of really weighty information, and I continue to feel like we're moving really quickly. It feels really rushed, even just in being able to digest the information that's being presented. So appreciate the efforts thus far to transparency and engagement, and offer this feedback in terms of continual improvement. And again, we'll reserve my specific comments for later. So thank you.
Thank you. I appreciate the feedback. Just to clarify, yes, we do have additional sessions planned in a little bit here on dairy and livestock methane, as well as methane from waste activities, and that includes some deeper dives from other state agencies and environmental justice advisory committee representatives and industries. So yes, look forward to your comments as part of the sessions, and we'll have a public comment portion for the sessions, as well as time carved aside for additional EJ advisory committee members. And then finally, just I think Jeff also suffers from a similar affliction that I do, which is that we're fast talkers. We appreciate the feedback. Certainly ask him that he slows down a little bit on this the presentation going forward, and yeah, appreciate the feedback.
Okay, I do not see additional members of the Environmental Justice Advisory Committee. Thank you for your comments.
Great, thanks. So I guess I'll hand it over to Jordan for the general public comment process. Do we have hands raised?
Thanks, Jeff. Yes, I see 11 hands raised right now. So the first three that we'll call on are Nancy Gonzalez, then Kristen Tedonio, then Julia Levin. And actually, Nancy, it looks like your audio disconnected there. I don't have an option to unmute you, so I'll come back to you. So let's go ahead and go to Kristen. Kristen, you can unmute yourself and begin.
Hello, thank you very much. Kristen Tedonio here, a Senior Climate and Energy Advisor with the Institute for Governance and Sustainable Development. Today I'd like to comment specifically in response to Glenn Gallagher's key questions on HFCs, specifically what additional strategies could be used to reduce HFC emissions, how to address those banks, and how to preserve the benefits of building electrification when a lot of electric devices still use HFCs. I wanted to call all of CARB's and the participants' attention to a recent decision by the California Public Utility Commission, specifically Decision 2105-031. And the reason that this decision was really important, on page 60, they offer some very clear direction to all energy efficiency program administrators in the state of California. And as many of you on the call know, while CARB may have a limited budget to address HFCs, the efficiency programs in California spend upwards of $1 billion a year on these efficiency programs. So it's a good opportunity for synergy. So specifically on page 60 of this order, the PUC directs program administrators to consider and incorporate strategies to support the use of low global warming potential refrigerants in their upcoming business plan filings. And they encouraged the program administrators to seek out all cost-effective opportunities to incorporate these low GWP measures. So why is this significant? I think there's a huge opportunity for CARB here if you have the ability to dedicate staff time to work with CPUC to review those business plans that the utilities and their program administrators are going to be filing, and to help guide them towards actions that are going to have the biggest benefit towards helping you achieve your HFC reduction targets. Very specifically, we have proven in some analysis before that if utilities were to direct some efficiency program dollars to help, for instance, supermarkets transition to low global warming potential refrigerants in advance of their late 2020 to 2030 deadlines, that could have huge benefits. In addition, using that ability of utility efficiency program administrators to aggregate old equipment and make sure that refrigerants are not vented but are properly recovered and recycled or disposed could make a really big difference. And then finally, on preserving building electrification benefits, I think you all know what you got to do. You got to make sure that those SNAP rules you instituted, the bans on end-use products, are being followed and abided by. And probably you need to expedite other sources of HFC growth, specifically heat pumps, water heaters, making sure that they are transitioning to low GWP refrigerants as well. So thank you very much.
Thank you. This is Elizabeth Shealy. I'm the Research Division Chief. I just wanted to thank you for the information, and we will continue to work with the PUC and the CEC on their programs. This is obviously a very important sector, and we want to collaborate with our sister agencies. So thank you for the comments and the suggestions.
Sure thing. Make sure every utility is doing it.
Thank you, Kristen. Our next question is from Julia Levin. Julia, go ahead.
Good morning. This is Julia Levin with the Bioenergy Association of California. I want to thank the Air Board for maintaining a focus on short-lived climate pollutants. The climate catastrophe is already upon us, and climate scientists are clear that this is really our last lever to avoid totally catastrophic climate change. So thank you for continuing to focus on this critical area. I have 3 comments in reaction to this morning's presentation, all related to black carbon. The first is I really urge the Air Board to have a specific focus on eliminating diesel as quickly as possible. Diesel is a major source of black carbon, but the way that your charts break down the different sources by sector never really highlights how critical it is to get rid of diesel as fast as possible. And this means particularly from heavy-duty trucks that are the largest source of air pollution in the San Joaquin Valley and the South Coast Air District. It also means stopping this massive proliferation of diesel backup generators and diesel in other uses as well. My second comment is regarding what is anthropogenic black carbon. I just cannot understand from a legal, a scientific, or a common usage standpoint how you avoid including things like prescribed fire or human-caused large fires, whether it's utility power lines, substations, motor vehicles, human campfires that cause these large fires. How can you not classify those as anthropogenic black carbon? And it's significant because the failure to do so means the financial incentives, the penalties, the trade-offs, even what we prioritize in terms of addressing, we're not dealing with it. And I understand that it makes our climate progress look even less positive, but if we don't call it for what it is, we're not going to solve it. And anthropogenic black carbon includes a lot more than wood stoves and a few other sources. We have to deal with all of the sources of human-caused fires. My third point is in reaction to a question early in the Air Board's presentation about how to use biomass. That doesn't really seem to be on either the first part of the agenda or the later agenda, so I want to address it now. I think it's very, very clear from the science that the highest and best use of biomass is converting it to energy and biochar, which can be returned to the soil for carbon sequestration or provide a lot of other benefits. But when I say bioenergy, I'm not talking about the old biomass combustion facilities. I'm talking about advanced technology moving away from combustion to renewable gas and renewable hydrogen. And circling back to my first point about diesel, which I think is one of the most critical things we can do for the climate and air quality, the way to get rid of diesel right away is to replace it with renewable gas, particularly RNG and renewable hydrogen. Thank you.
All right, thank you, Julia. Our next question will be from Bill McGavern. After that, we'll have Christiana Darlington and Muriel Strand. So Bill, you can now unmute yourself.
Thanks. Good morning. Bill McGavern with the Coalition for Clean Air. I want to thank Kevin Hamilton for his comments and also the staff for a presentation that was really packed with information. It's good to find out that a lot of the measures that I've worked on over the years are actually reducing emissions, like the oil and gas methane rule and the whole suite of measures to reduce diesel emissions. But clearly we need to do more, and I'm glad to see that the staff presentation recognizes that we need to do more. And there's obviously a whole lot that needs to be done. I think we look at methane, the dairy sector is the biggest emitter, so we need to actually have regulatory measures in the dairy sector for their methane emissions. And also in the waste sector, we need to move a lot more quickly and robustly to implement SB 1383's requirements that we stop putting organics in our landfills. When it comes to black carbon, Julia Levin beat me to it. We have to phase out diesel, which will have, enormous health benefits as well as climate benefits. And the state does need to move as quickly as possible to get off of diesel. There are a lot of ways that we can do that. And, while we're still using diesel, we should make it as much as possible renewable diesel, which is lower in black carbon emissions. And when it comes to stationary sources, we need stronger rules to reduce emissions from refineries and from wood burning. Thank you very much.
Thank you. Our next comment comes from Christiana Darlington. Christiana, go ahead and unmute yourself and begin.
Hi, this is Christiana Darlington. I am calling on behalf of the Placer County Air Pollution Control District. Thanks for the presentations and continuing to work with the air districts and CAPCOA on different issues. From our district's perspective, we wanted to emphasize today that the research that CARB has been doing in terms of black carbon needs to continue and essentially restart. We haven't seen any technical reports out of the Air Resources Board in a couple of years, and this is a critical area of research that we continue to emphasize and that is needed. Second, we hope that there'll be better coordination between your efforts in the Working Lands Plan and that coordination into the scoping plan, as well as the forest carbon plan that you mentioned. The coordination is that no one is specifically addressing smoke from wildfire and its impacts, whether it's considered anthropogenic. That would be a great option, as Julia Levin mentioned. Whatever option you choose, though, you must directly address this and start talking about different tools, recognizing that it is not a gas and it is not covered as such. It still needs more direct attention, and our air district really encourages you to work on those issues, and we'll make ourselves available for consultation on that too. Finally, I wanted to mention that Title 17 We feel and we have lots of evidence to show that Title 17 still regulates prescribed fire and agricultural burning in a sufficient way, and that the air districts approve over 98% of all prescribed fire recommendations and apply those. And we have lots of evidence about how we effectively manage those types of burn programs at the local level. And we'll continue to implement Title 17, that there are other techniques and tools to help with that. But again, prescribed fire needs to be addressed in the short-lived climate pollutant plan or somewhere. And so we're just hoping that, we can start working together with you to figure out which of these avenues you can more work with these issues directly. Thanks for your time.
Hi, Christiana. Thank you for the comments. I just want to make a clarifying point. So we are also working on, as part of the 2022 scoping plan update, updating the targets for natural and working lands. And as we presented, I think it was last month, maybe the month before, as part of our Natural Working Lands Technical Workshop, we are underway with a modeling effort to look at what the state of natural working lands, specifically forests, could be under various carbon neutrality scenarios. We sought some feedback as part of the public workshop, and they're also looking forward to feedback from the EJ Advisory Committee as well. And part of that work includes looking at the effect of various management practices on carbon stocks in California. And so, one of those management actions obviously is prescribed fire. The work is complicated. Modeling forests and modeling management actions across the state takes a lot of resources. And so we're also trying to evaluate how we can look at the particulate matter emissions associated with those management actions, but still a lot of work to be done there. So look forward to engaging on those topics as part of the National Working Lands work, and just wanted to flag that it is something that we are looking at in that process. Jordan, next comment.
Thanks, Matt. Next is Muriel Strand. Muriel, go ahead and unmute yourself and begin.
Hi, I'm Muriel Strand. I am a retired air resources engineer. And this is a little out of left field, but yesterday I Googled methane and plastic. And it turns out that plastic does, as it degrades, slowly off-gas a certain amount of methane. Now, I have no idea about the magnitude, but as we all know, there's lots of plastic all over the place, and some of it is waste plastic, and some of it is still in use. And I don't know if you've looked at that, and the magnitudes could be significant or they could be, minimal, but I just wanted to kind of put that on your radar screen.
Hi, Muriel. Thanks for the comments. I just want to flag that in a little bit here, we'll be hearing presentations from CalRecycle, CARB, and others about progress in reducing emissions from the waste sector. And what you'll hear as part of those presentations is that, by and large, the methane emissions coming from the waste sector come from our organics that are deposited in landfills and/or that are degrading. So, encourage you to stay on the line and watch that presentation as we talk about methane from waste.
All right, our next comment will come from John Constantino, followed by Stacy Heaton and Colin Miller. So John, go ahead.
Thanks, Jordan. I had a question related to what Jeff said right at the very beginning. It sounded like he said this is only in-state emissions. And I was wondering how carbon neutrality accounting was going to work for RNG that is brought in through the LCFS program. So I'm not sure who to ask that question to, or if it's a question for later on this afternoon, but I just wanted to get a clarification whether we're talking in-state only and the inventory associated with that.
Yeah, thanks, John. So I think just a point of clarification. So obviously today we're talking about what our greenhouse gas emissions are in California, our SLCP emissions in California. We're looking at our evaluation towards our 2030 targets that are set in 1383, and we track and evaluate progress towards those targets using our AB32 emissions inventory, which looks at in-state emissions. The concept of kind of RNG out-of-state emissions and kind of RNG pathways. That's obviously stuff that we're going to be talking about a little bit later in the workshop. But I want to just kind of flag that, what we are looking at right now for HFCs, for methane, for black carbon, we're following the framework that's set out in our inventory that follows IPCC best practices and guidance.
All right, our next comment is from Stacy Heaton. Stacy, go ahead and unmute yourself and begin.
Stacy Heaton with the Rural County Representatives of California. Appreciate the opportunity to comment here this morning. We represent 37 rural counties statewide, and our member counties, many of which are in high wildfire risk areas and have many socioeconomically disadvantaged communities, continue to be frustrated at the bifurcation of this discussion from the wildfire emissions discussion. And we've long maintained that those emissions really need to be folded into the larger discussion and not just left to an isolated forest carbon discussion, particularly since the state has slowed or even delayed action for up to a decade now on forest health and fuels treatment projects that probably could have prevented a lot of the wildfire activity we're seeing now. We believe the state's wildfire emissions are largely due to how the state's forests and wildlands have been managed, which has now been exacerbated by climate change and human activity. And we continue to feel like this needs to be examined in the complete scope of short-lived climate pollutants to help elevate the importance of it. And thank you, that's my comment.
Thank you. Our next comment is from Colin Miller. Colin, go ahead.
Good morning, everyone. My name is Colin Miller with Environmental Justice Solutions. I'm calling in as an alternate for Marta Dinarguello, the Director of Physicians for Social Responsibility, Los Angeles, and co-chair of the EJAC. Although Marta Dina could not make it to the public workshop today, she asked me to speak on her behalf to express strong opposition to the use of biomass, dairy, biogas, and biomethane as climate action strategies. PSRLA supports our coalition allies in the Central Valley and feel that these are false solutions to the climate crisis that will both perpetuate emissions from combustible energy sources and perpetuate environmental racism. PSRLA recognizes that the use of these technologies will harm public health and will disproportionately harm environmental justice communities, low-income communities of color. Thank you.
Thank you. Next is Stephen Jepson. Stephen, go ahead.
Hi, thank you. This is Steve Jepson, the Executive Director for the Southern California Alliance of Publicly Owned Treatment Works. We represent over 80 public agencies in Southern California that provide water, wastewater, and recycled water to their communities. We've heard mentioned the need to divert organics under SB 1383 and also AB 1826, which addresses food waste. And wastewater treatment plants are an excellent pathway for diverting food waste that could be diverted to wastewater treatment plant digesters and produce a wastewater derived biogas that can be used to more quickly get diesel vehicles off the road and provide a truly renewable energy source for transportation that is 90% lower in NOx than diesel. And the POTW digesters already exist. We're already producing this gas, and it can't be turned off. It's part of cleaning up water for the environment. We would like to see this source of wastewater derived biogas included in the scoping plan as a way to provide transportation fuel and more quickly get diesel trucks off the roads and provide a pathway towards attainment for some of our air districts that are in non-attainment. I understand that this topic may be addressed in more detail later on, but I wanted to get the comment in now because sometimes we run out of time in other segments for public comment. So thank you for taking my comment.
Thank you, Stephen. All right, I see one more hand up, and it's from Nicole Rice. So Nicole, go ahead.
Yes, good morning. Can you hear me?
Yes, I can.
Perfect, thank you. So this is Nicole Rice. I'm president of the California Natural Gas Vehicle Coalition. And I just wanted to make a few statements regarding black carbon. I wanted to agree with the comments that have already been made, that black carbon is a huge problem that needs to be addressed to meet our climate crisis and to meet the goals that were discussed today. I want to align my comments with those that were made by Julia Levin and others regarding the need to address diesel usage, especially in the transportation sector, and to look at ways to reduce diesel usage in vehicles to thereby reduce the emissions. And wanted to also align with the comments that were just made by the previous speaker of looking at renewable natural gas powered vehicles like low NOx heavy duty trucks as a best immediate solution to address getting diesel vehicles off the road. This technology has proven to be 90% cleaner than diesel in heavy duty transportation and vehicle sectors. And as we continue to work through this transition to cleaner fuels and technology use, we do have a proven technology today that is on the road today, that is supported by infrastructure today, that has been invested in by the private sector. And we have a pathway by which we can begin to make significant strides in addressing not only our federal attainment goals, our climate goals, but also our air quality goals. And so we just urge CARB and the staff to continue to have that technology in the mix and continue that discussion as you are considering the updates to the scoping plan. Thank you.
Thank you, Nicole. We had a couple more hands come up, so I'm going to go ahead and go through those in the order received. So Denny Zane, I see you first here. Go ahead.
Hi there, my name is Denny Zane. Can you hear me?
Yes, we can.
Okay, good. I'm Executive Director of Move LA. I would like to, first of all, thank CARB staff for this workshop on this critical issue. If indeed we have a decade to reach targets, this work that you are doing now, the planning you are doing now, is crucial for that decade to go successfully. And for that decade to go successfully, I really do believe we need to emphasize the end of use of diesel vehicles and diesel engines in all capacities, not only because they're a major source of carbon dioxide and carbon, but also because they're a major source of NOx, which generates tropospheric ozone, another one of the short-lived climate pollutants, and frankly, carcinogenic diesel exhaust is one of the few fuels that's used commonly in California, which has made the top 65 list of toxic air contaminants. Diesel is bad stuff. We need to get rid of it quickly as possible. The advanced clean truck rule is a good start. We probably need to strengthen that, but we're going to need major incentives to accelerate this turnover. Significant funds that manufacturers can look to know that there's going to be a market vehicles that they're going to produce, and those funds need to be very significant, need to be reliable, and they probably need to be envisioned as longer term. The only thing that will give manufacturers the confidence there is a market, that they can rely upon it, that there's going to be, in fact, an industrial system created to support alternatives to diesel. The next 10 years really are crucial. We look to you to identify the best strategies in the short term as alternatives to diesel. They may not be strategies you will retain for the long term. I also suggest to you, as part of addressing concerns about renewable natural gas and its identification, I think, incorrectly with fossil gas, we ought to be looking to transitioning our pipelines away from fossil gas toward renewable gas and hydrogen. And I think that means you should be considering a program rather like the RPS for the power grid, where there is an ever declining share of of the gas in the pipeline is fossil gas, to the point where we in fact can phase out fossil gas. Finally, I want to suggest that it's my belief that the only source of revenue that can go to scale here, be reliable over a significant several decades period, is likely a ballot measure that voters will vote on. And one of the things you should be considering is a plan that the legislature could adopt for a ballot measure before voters in California. We have had some polling conducted on similar kinds of measures and found over 60% support. So if we had 60% support on a measure that needs only 50%, provide $3, $4, $5 billion a year in resources to invest in incentives and infrastructure away from our current practices. That, I think, is a strategy that only fools would avoid. We are not fools. We are California. What California does leads the world. Thank you.
Thank you, Denny. Next, we have Malon Aldridge, followed by Cedric Twite. Malon, go ahead and unmute yourself and begin.
Hi, can you hear me?
Yes, we can.
Okay, great, thank you. And thank you for this great workshop. I wanted to, I'm with Ecology Action. I'm Vice President of Strategy. Ecology Action is a nonprofit that works throughout California to help businesses and individuals improve their performance for climate impact performance, and particularly wanted to comment today on the focus on HFC reduction. Very supportive of that. We have, over the last 20 years or so, served thousands of grocery clients and grocery chains throughout California and also in other states, 24 other states. They're, a huge part of the HFC puzzle. I wanted to speak particularly on the 2,000 independent grocers in California and the impact of this legislation and the phase down on them. Very important players in this from an environmental standpoint, and also from an environmental justice standpoint. The independent grocers are ones that might be a mom and pop shop, just one or two. They might have a chain of might have a chain of 20. And they're most often the local grocers that are the first thing for a community between, that are on the edges of food deserts, places where people don't have access to good food and good produce sections. And so, and just a robust sort of selection of food. Grocers are moving out of these areas because it's very hard for them to be profitable. And the cost to do the HFC conversion for these grocers is it ranges from $100,000 to $2 million, depending on how it's done and the condition of the facility as a baseline. So my encouragement is to really look at solutions that will help the independents not be so burdened that they go out of business in these areas where we would lose jobs and lose, the food for these areas that are near food deserts and disadvantaged and underrepresented or under-resourced communities. The larger companies, large chains like you would think of, like Walmart and Costco, they can afford to focus on this, whereas the independents can't, and they're many times on the edge of leaving already. There's an approach that's been used very successfully for similar businesses that are hard to reach and in sort of disadvantaged areas. It's called direct installation, and it's a way to really help from start to finish, bringing all the technical capabilities needed, aggressive rebates, and helping bring together the jobs so that these businesses are able to focus on their main business and get these conversions done In that case, it was efficiency, but it's been used throughout the state and the country, actually. So it's a great model. So just advocating for special focus on that model of approach with very aggressive incentives for that particular sector. Thank you.
Hi, thanks. This is Elizabeth Shealy again. I just want to thank you for your comments. We have heard and kind of understand those concerns. On the retail food side, we have actually incorporated a mid-step in there for small businesses and smaller grocery stores to meet our longer term goals, and are always looking for ways to assist in that as well. The cost of technologies will come down over time, with the refrigerant being a smaller cost of the overall technology. And as that gets proven out through the work we're doing and some of the incentives that you mentioned, using and implementing CO2 systems and different systems in grocery stores and helping get familiarity with those, and happy to talk more about that. Thank you.
Thanks, Elizabeth. Our last question is from Cedric Twite. Cedric, go ahead and unmute yourself and begin.
You hear me?
Yes.
Great. My name's Cedric Twite. I represent Sierra Pacific Industries, which is a family-owned, vertically integrated forest products company that manages just a little over 1,800,000 acres of forest here in California. My comment today is just to encourage CARB to carefully consider how it quantifies black carbon from wildfire emissions as it relates to its contributions to the state's greenhouse gas goals, because it will act as a double-edged sword relating to meeting the state's climate goals. For example, if CARB ignores black carbon from forest fire emissions, then it will encourage or at least not punish prescribed fire projects for their emissions, which do help reduce the threat and cost of wildfire prevention and suppression. However, by ignoring the impacts of fire emissions, it will not allow the public, including policymakers, to appropriately value the positive benefits for greenhouse gas emissions, public health impacts, and fire prevention and suppression cost savings that can be achieved by disposing of excess forest fuels through alternate bioenergy disposal pathways instead of prescribed burning. California's excess forest fuels, which are powered by photosynthesis, so as green as it gets, are currently powering uncontrolled wildfire, emission plumes, and costing the state hundreds of millions of dollars annually in fire suppression and prevention costs. Instead of as bioenergy for both baseload electricity and hard to electrify sectors such as long-haul trucks and aviation fuels. Therefore, CARB should not ignore black carbon from wildfire emissions, because by doing so, it will not adequately value the greenhouse gas, health, watershed, and economic benefits that the bioenergy disposal pathways can provide. Thank you.
Thank you, and that concludes the Q&A period for this first part of the workshop.
Thank you, Cedric. I appreciate the comments, and we'll flag that this is also one of those questions that we did ask as part of the scenario building workshops, where we were seeking feedback on kind of what should be the role of biomass in the energy system, and looking to also understand the EJ Advisory Committee's input on that one as well, as we think about what are the feedstocks and the energy end uses for California under various carbon neutrality pathways. So I think this may be a first. We are slightly ahead of schedule. So what I'm going to do, I'm going to ask Jeff Kessler to hop on and do just a quick overview of the part 2 of the day on dairy and livestock methane and organic waste. And then we are going to take a little bit of a break till 11. So Jeff, if you could do that quick overview.
Yeah, sure. Part 2 of the day is really structured around 2 main sessions that are going to occur. There's a session that covers dairy and livestock methane emissions, and we have panelists from CDFA, CARB, environmental justice, panel, and then an industry representative as well. And then section 2, after we return after the dairy and livestock session, will be covering landfill, methane, and organic wastes. And so we have discussions from CARB, CalRecycle, and then we also have dedicated time for the renewable natural gas discussion portion, which we've already started hearing from some of our comments. And so we have, again, an environmental justice advisory council member speaking for that, and also a representative from industry. And then we'll conclude the day with a second public comment period from the general public, and also anyone on the EJ advisory committee as well. So I think that should do it, which gives us about 15 minutes until 11 o'clock. So let's all meet back up here for that.
All right, thanks everybody.
Good morning and welcome back to the workshop. We're about to kick off part 2 here. I hope everyone managed to refresh their coffees and grab a little bit of a snack or something. So part 2 of this workshop is going to really start with the dairy and livestock methane section, and then we will move on to a section that covers landfill methane and renewable natural gas pathways. First up, we're going to have a short presentation from Ami Gunastakara. He is the science advisor to Secretary Karen Ross at the California Department of Food and Agriculture. Ami, go ahead and take over.
Hi, thanks, Jeff. Good morning, everyone. Happy to be here representing CDFA. As Jeff mentioned, I'm Science Advisor Secretary and I'm manager of the Office of Environmental Farming and Innovation. Next slide. So in the Office of Environmental Farming and Innovation, we have several climate smart ag incentive programs, 2 that are focused on methane. We have several demonstration projects related to the Healthy Soils program. We work on information sharing, connecting growers, and making sure we have practices that help with reducing our greenhouse gas inventory numbers. And then we do a little bit of research as well. Next slide, please. So I just want to start by saying a lot of what we have done under the Climate Smart umbrella at CDFA has been through some strategic initiatives on really listening to the farm and ranching community and also the agriculture community and a wide group of stakeholders. And these comments and feedback are memorialized starting in 2010 with AgVision. There was Strategy 9 and 7 that spoke to the importance of climate change and also expanding environmental stewardship on farms and ranches. Subsequently, there was AgVision 2017 that also was an update to the 2010 document that spoke of Strategy 4 or 5 strategies about resource preservation and stewardship. So, and then more recently, there was an effort as part of our governor's executive order last year in September to have farmer and rancher-led climate solution listening sessions, which we did. We're still working on the final report with recommendations, but that also talked about the need for small farmers also needing support and financial support because the risk associated with investments in new technology and equipment, including climate smart ag practices. And I included some links below where you can find these documents very easily. Thank you. Next slide, please. So this is a screenshot of our main web page on the Climate Smart Ag umbrella of CDFA. As I mentioned, we have several programs under that. And I will talk today quickly about the 10 minutes I have about 2 methane focused programs, the Dairy Digest Research and Development Program, and then the Alternative Manure Management Program. Next slide, please. Okay, so quickly about the Dairy Digester program. What this does is when we have dairy manure that is in a liquid state, it goes into a lagoon, and in anaerobic conditions, we have methanogenic bacteria that form as part of that system, and what you get as a result is methane gas being emitted from those lagoons. So what this program incentivizes is to cap that lagoon with a plastic barrier, and then you capture that methane gas, and then the methane gas can be used either in an IC engine to produce electricity or put into the natural gas pipeline for further use in commercial and domestic or industrial uses. So that's an overview of how the system really works. On the top, let's see, right-hand corner is one of the lagoons that have been capped. You can see that sort of plastic barrier bubbling up, and that's the methane gas building on there. And then also a similar picture on the bottom left is, the plastic barrier sort of like popped up because this methane gas is being captured and used over the lagoon. So this program was created in 2015. We give out $2 to $3 million grants. They must have at least 50% match. We know these projects cost way more than $2 to $3 million. And you can see that from the matching funds here, which are almost double that of the awarded project. So we have awarded 196 million to date, and total matching funds from the industry and from the ag sector, 400 million that have been contributed to these projects from those applicants. We've funded about 118 projects. This is one of the highest greenhouse gas reduction programs in the state. And we have a pretty high oversubscription rate, which tells us that this program is very popular and folks want to implement more of these. As I mentioned, the gas can be used both for renewable electricity and also renewable natural gas. The co-benefits are many, and there are several environmental protections. For one, we make folks double line the lagoon to make sure that we get the highest water quality standards under the lagoon, and make sure that that lagoon is not leaching nitrates into the groundwater. Regardless of where it is in the state, we make them do the double lining lagoon for nitrate protections there. We also, the other co-benefits I will briefly mention is you get odor reductions, and then you can also have particulate matter reductions if you move, as we see projects move away from IC engines towards pipeline injection for natural renewable natural gas. Next slide, please. These are some images of what goes into a dairy digester project. The cap, of course, is a big part of it. We have an IC engine here. As I mentioned, a lot of the projects have moved to gas line and pipeline injection, which helps with particulate matter. A lot of it is automated, and we verify that the greenhouse gases are captured and are flowing and destroyed. So next slide, please. So when we developed the dairy digester program, we had a lot of requests for non-digester practices to be included as well in manure management, and that is memorialized on the alternative manure management program. And so we have funded about 116 projects to date. So these are practices that you can do to reduce methane from livestock and dairy operations without using a digester. So what we see is moving away from wet systems to dry systems. We see with that top left image, and then next to it we see a solid separator pulling out the solids. The solids are what the bacteria use to chew on, if you must, and produce that methane gas. And then we also have things like increased pasture time, which then reduces the slurry and wet system that gets collected somewhere. It is also popular, 317% oversubscription rate. It doesn't require match. These are more akin to smaller dairy systems. So we don't require that match. Next slide, please. So all these go towards, as you can see here on the left, pie chart is our inventory at 8%, and this is somewhat deceiving because it's not all from cows. About 4% of that 8% is from methane emissions from manure management and enteric fermentation. Of that 4%, 2% is from manure management. So that's what we're trying to address with these programs by trying to reduce that 8% by about 2% over time. There are some goals that have been set, SB 1383, obviously, 40% reduction below 2013 levels by 2030, and then several executive orders to reach carbon neutrality. You know, in the past scoping plan, I took an image, that's the bottom right image, and it talks about all the different strategies. And, you know, we're tapping into the 50% renewable energy. We are tapping into the carbon storage in the land base. And then we're addressing short-lived climate pollutants as well. So these programs really support the scoping plans in the past. in terms of greenhouse gas mitigation, but we also see it as a adaptation to a changing environment as well. Next slide, please. Okay, so we have certainly experienced some challenges in this program. I just outlined a few here. Certainly there are more that we can, highlight. But one of the things we did is we saw COVID-19 delays that came about from getting the materials needed to build these projects that were already awarded. So there were some extensions granted there. Permitting and interconnect delays can be an issue too. There's a lot that's happening on interconnect these days from the utilities, and there's just general delays on that end. Increased cost of supplies, we have seen inflation rise over the last 2 years, and also with COVID-19 delays. Milk prices are very volatile, so we've seen dairy struggle with that. We feel like dairy digesters are one additional revenue stream and project that can help with volatile milk prices to help folks stay in business, and also provide local jobs and benefits to those working around any dairies. The liquidations associated with funding, we get funding, but they have certain encumbrance and liquidation dates, which have put, with these projects are big construction projects, so that puts some sort of pressure on the liquidation deadlines, which we have had to ask for extensions using a budget change proposal. And then annual funding can be challenging for long-term certainty. This is something we have talked about a lot. How can we get consistent funding for long-term solutions from methane capture from dairies? And then what about the other 2%? So we are really addressing the 2% of the 8%, but there's another 2% that's focused on enteric that needs some solutions to come along. Quantification of co-benefits, we know that there are these benefits, but we haven't quantified them well. So something to certainly think about and work on. We don't have a lot of solutions for plug and play nitrogen capture technologies at the end. We would love to see some technologies where you can pull out that nitrogen and then move it to places where there's not a lot of nitrogen, but the plants need it to balance out the nitrogen distribution in the state and help the nitrate issue. Manure-based products, that's another one. What kind of products can we get out of these manure systems that can help ag and contribute to other environmental sectors. Need for improved quantification methodologies. Certainly there is a need to improve the emission factors related to these certain practices, and that's something we have, and the ARB has also contributed funds to trying to understand further and get the right methodologies and emission factors associated with those practices. And then I think from our perspective, we really need to show the economic benefits of this a little further on how we can really help growers continue to stay in business and have their families continue to operate these dairy systems in this state. Next slide, please. Thank you. So that's a really quick overview. My contact information is here. This is some of the few folks who work on administrating this team, way more important than I am. Thank you.
Thanks, Ami. We can go to the next slide. So we still have quite a few additional presentations left in this part of the workshop. Next, we're going to hear from Chen Mittliner. She is in CARB's short-lived climate pollutant policy section, and she will be providing a status update on livestock emissions. And that will be followed by Michael Bocadera from West Coast Advisors, and Jay Jordan will conclude the dairy and livestock section of this workshop. So go ahead, Chen.
Thanks, Jeff, for the introduction, and good morning, everyone. My name is Chen Mittliner, and I will be presenting to you the dairy and the livestock portion of the work today. Next slide, please. So this slide shows California's methane. Previous slide, please, Jordan. Yes. Right here, thank you. So this slide shows California's methane emissions in 2013, which is the baseline year set by SB 1383. Current emissions reflected in the latest GHG inventory show methane emissions remain largely the same compared to the 2013 levels. The pie chart on the right side shows that California's dairy and the livestock emission operations remain the largest source of statewide methane emissions, emitting approximately 22 million metric tons CO2e in 2013, which accounts for over half of the state's methane emissions. These emissions can be roughly split evenly between enteric and manure emissions. Staff calculated the 2030 target by multiplying the dairy and livestock sector's 2013 methane emission levels by 40%, which is about 9 million metric tons CO2e in methane emissions reductions. Next slide, please. This slide shows a high-level overview of methane mitigation strategies for dairy and livestock manure and enteric emission sources. As Ami discussed in detail in his presentation, methane emissions from manure management can be reduced using anaerobic digesters or alternative manure management practices, so I will not elaborate on these strategies. Instead, I will focus on providing some information on enteric mitigation strategies. Methane emissions from enteric fermentation can be reduced through a variety of approaches. These approaches include selective breeding, diet modification, as well as feed additives, which is an immersion area with significant methane reduction potential. Despite limited commercial options, research has suggested that these feed additives may deliver significant greenhouse gas reduction benefits between 10 to 50%. And the potential benefits of using feed additives include they offer a cost-effective pay-as-you-go solution that farms could adopt to reduce enteric emissions. And they can easily be implemented across a wide range of livestock operations. Some challenges associated with feed additive usage include there are currently limited financial incentives, and also there are limited options available with proven effectiveness. Next slide, please. In June of this year, CARB staff published a draft report analyzing the progress the dairy and the livestock sector is making towards the 2030 target. In the draft report, staff estimated the potential additional methane reductions needed from the sector by 2030. This slide shows the assumptions that CARB staff used to project potential methane emissions and the reductions through 2030 as part of that report. These assumptions address animal population change as well as manure management and enteric methane reduction strategies. On the population decrease front, a linear annual decrease in animal population of 0.5% is projected between 2013 and 2030. Due to lack of population projection data, staff assume animal population will plateau beyond 2030. For manure management projects, staff assumed implemented projects through both private and public funding will provide a total methane emissions reductions of approximately 2.2 million metric ton by 2022. Going forward, staff assume no additional investment will be made in manure management practices. And for enteric strategies, staff assume no implementation of enteric methane mitigation strategies will be implemented. Next slide, please. This slide illustrates projected methane emissions reductions through 2030 under the assumptions mentioned in the previous slide. It shows that the dairy and livestock sector is on track to achieve approximately 4.6 million metric ton of methane emissions in emissions reductions by 2030 through population reduction, digester projects installation, as well as alternative manure management and private projects implementation. These reductions account for just over half of the 9 million metric ton methane emissions reductions needed to meet the 2030 target. Under this projection, the dairy and livestock sector is making important progress, but we'll need considerable additional emissions reductions in order to meet the 2030 target. Next slide, please. So what we are showing on this slide is very similar data to the previous slide, but through the lens of absolute emissions from the sector rather than emissions reductions. So this slide illustrates the dairy and livestock sector's expected emissions through 2045 using the previous noted assumptions. The dashed green line on top shows the 2013 baseline, and the dotted red line on the bottom shows the 2030 target. As noted, the sector has made considerable progress, but will need additional reductions of approximately 4.4 million metric tons in order to reach the 2030 target. Next slide, please. The previous slide emphasized that we will need additional reductions to meet the target and reach deeper reductions by 2045. In order to assess additional reductions the sector might be able to achieve, we need to address some key questions on various fronts. Regarding animal population change, the question is, should we anticipate a continued decline in animal population? If so, how much? For manure management strategies, key questions are surrounding how many additional manure management projects shall we anticipate and how much funding might be available. The key questions for enteric strategies include what will the greenhouse gas reduction potential of enteric strategies be, and how widely will they be adopted and when. In addition, it is important to investigate if there are other strategies for reducing California's dairy and livestock methane emissions that we are currently missing. Next slide, please. With these questions in mind, staff developed an illustrative example with the following assumptions. First, staff assume animal population will decrease linearly at 0.5% through 2030 and plateau thereafter. For manure management strategies, staff assume annual public funding of $75 million will be available through 2028, sufficient to achieve the 2030 target. For enteric strategy, staff assume a potential enteric strategy with 50% mitigation potential and a 75% adoption rate by 2045. Under these assumptions, the sector is estimated to achieve nearly 13.5 million metric tons of methane emissions by 2045, surpassing the 2030 target, which is shown as the dotted red line here on the figure, by almost 4.5 million metric tons. Next slide, please. So this slide recaps the key questions we are seeking your feedback on. These questions include what additional strategies could we deploy to further reduce methane emissions from the sector? What amount of methane reductions pre and post 2030 shall we expect? What strategies will best support adoption of enteric methane reduction strategies? And what are the reasonable assumptions about their effectiveness and adoption rates? What are reasonable assumptions about in-state animal population change? And to what extent shall we prioritize or account for non-greenhouse gas outcomes of emissions reductions projects? Answers to these questions will help CARB set reasonable methane emissions reductions targets for the dairy and livestock sector beyond 2030 and identify potential strategies to reach deeper reductions. And we are looking forward to receiving your feedback on these questions. With that, I will conclude my presentations for today, and thanks very much for your attention.
Awesome.
And Jeff, I pass it back to you.
Thanks, Chen. So we have two more presentations left in the dairy and livestock portion of this. So we'll have Michael Bocadoro with West Coast Advisors presenting, and that will be followed by Jay Jordan, who will conclude the dairy and livestock portion of this workshop. So go ahead, Michael.
Thank you, Jeff. I'm Michael Bocadoro. I've had the pleasure of working with California's dairy sector for over 20 years on sustainability issues, where I've been involved in all efforts to date to reduce dairy methane in California. Next slide, please. California's dairy sector has made tremendous progress, as you heard from CARB and CDFA. This hasn't happened by accident. The state has made a tremendous commitment and investment of over $600 million to date in dairy methane reduction projects, and it's paying huge dividends. Private investment is matching that nearly 2 to 1, and total investment is rapidly approaching $2 billion, easily establishing California as the world leader in this area. In just a few short years since the passage of 1383, we now have nearly 300 dairy methane reduction projects built, under construction, or in the permitting stages. Even more are in the planning stages. This includes more than 150 dairy digester projects, with most of these projects being built in 12 active clusters that are currently being developed throughout the San Joaquin Valley. It is very important to note and understand that these are nearly all on existing dairies in the state. Very few new dairies have been built in California in recent years, and overall, we have seen a tremendous decline in the number of dairies in the state overall. It is also important to understand that California's dairy sector is no longer growing. Despite increasing demand for dairy in this country and globally, the number of dairy cows in California has declined by 6 to 8% since a peak reached around 2008, and dairy production, milk production, has leveled off around 2013 peak levels. As CARB noted, we expect that trend to continue. Roughly the same number of production, same level of production, but with fewer cows each year as production efficiency continues to allow us to produce more milk with fewer cows. Next slide. Efficiency is king. California's dairy sector is a world leader in efficient milk production. We're producing more milk with fewer cows today, and this has led to important environmental benefits across the spectrum. Production efficiency is critical and driven largely by improved animal health, comfort, and nutrition, more efficient farming and feed production, and high utilization of agricultural and food waste as highly nutritious feed. Byproducts such as almond hulls, cold fruit, and bakery waste accounting for over 40% of the total dietary ration on many dairies in the state. Over the last 50 plus years, efficiency has provided dairy production to occur with 89% less land, 88% less water, significantly less fossil fuels, less energy, fertilizer, and pesticides, and most notably, a 45% overall reduction in the carbon intensity of each gallon of milk produced. Production efficiency is critical and will continue in California. It will also be particularly critical for other regions of the world. Next slide, please. As we move forward, you heard from CARB, while we have made tremendous progress in reducing dairy methane in 4 short years since passage of 1383, more progress is necessary to achieve the 40% reduction in both manure and enteric emissions sought by the state. This will necessitate a continued all of the above strategy as outlined here. More digester projects will be needed and funded and built in California, at least 100 more, and this will prove more challenging as we move to development on smaller and smaller dairies. More alternative manure management programs will also be needed, but these projects alone cannot achieve the 40% reduction in manure management emissions sought by the state. Reductions in enteric methane will also be necessary, and we expect several feed additives to be commercially available in the next few years. These feed additives can achieve enteric reductions in the 30 to 50% range. It is critical that these be shown to be safe for animals, cost-effective, and economical for producers to use. To facilitate their utilization, the dairy sector is already working on the development of an enteric emission feed additive emission reduction protocol. This will prove critical for widespread adoption by the industry. Ongoing production efficiency improvements will also prove critical as more opportunity exists to produce more milk with fewer cows, especially in the areas of cow nutrition, comfort, and selective breeding practices. Additional research will also be necessary as we move forward, particularly on enteric emission reduction strategies, new methane reduction strategies, and documenting, as Ami mentioned, the significant environmental co-benefits in air and water quality that these projects can achieve. Next slide, please. As we move forward, it is also critical that we continue to proceed smartly and strategically. We have shown the incentive-based approach established by 1383 can work effectively. If we continue to get this right, we can and will achieve the state's goals of reducing dairy and other livestock methane by 40% by 2030. The discussion needs to be honest, solutions-oriented, and science-based. We cannot allow ideology to drive this discussion. It is far too important. It will lead to failure by the state. No one will follow our lead, and leakage will occur and result in higher overall global methane emissions from the sector as production simply shifts to other regions of the world that produce milk with a much higher climate footprint than we do here in California. Moving backwards to more smaller pasture-based operations is not feasible or a realistic solution in California. Suggestions that turning dairy manure into carbon negative transportation fuel, renewable electricity, and organic fertilizer is somehow not renewable is also misinformed. That is the very foundation of recycling, renewal, and regeneration that we should be seeking from the agricultural sector. In a word, it is frankly remarkable, and our family dairy farms should be lauded, not criticized for their efforts. Continued investment will also be critical, as documented by CARB earlier. To that end, the Newsom administration should be applauded for stepping up and providing $32 million this year in the budget and an additional $48 million next year to CDFA's ongoing dairy methane reduction efforts. This is falls short a little bit of the $75 million identified by CARB, but it represents a good start and continued commitment. Equally important, we need to continue to examine and address overall dairy sustainability. Digesters and other manure management projects, while they can provide important environmental co-benefits on water quality and air quality, they are not a silver bullet. There is no question they provide important environmental benefits and greatly improve the carbon footprint of the sector, but more can and is being done to further address the impacts and concerns, particularly those highlighted by disadvantaged community activists. On the water quality impacts, California is spending more than $130 million each year to address groundwater contamination in disadvantaged communities. Dairies and other farmers are establishing nitrogen management zones to both fund and supply drinking water in disadvantaged communities where it is most needed in the short term. And CDFA and state and regional water quality regulators have initiated a discussion to further improve nutrient management on dairies throughout California. Finally, we are working on technologies that can both reduce methane as well as nitrogen on dairy farms, or be utilized as bolt-on technologies on the back end of digester systems. On the air quality front, we know digester projects provide low carbon clean fuels that replace diesel and heavy duty freight. We know these projects capture and reduce hydrogen sulfide emissions from dairies, dramatically improving odor and nuisance concerns. And we will also be firing up the first dairy biogas to fuel cell to electric vehicle transportation project in the next several months, also providing another clean air improvement opportunity and clean transportation opportunity. Next slide, please. An honest and science-based discussion will also require us to re-examine and recognize the role of methane on climate. Two recent UN reports, Code Red and Global Methane Assessment, document the role of CO2 as the primary climate driver, and the important role of methane reduction in mitigating the impacts of continued CO2 accumulation and warming impacts in the short term. While methane is more potent, because of its short-lived nature, it is also an important opportunity to mitigate the long-term impacts of CO2 that are much harder to address because they will continue to accumulate for hundreds of years. As a result, reducing methane is critically important, both for the climate and air quality, as identified by the IPCC. Importantly, both of these reports recommend dairy and livestock methane reductions that are consistent with the approaches currently being undertaken by California and the approaches I have outlined here. This is also the approach being taken by the US, Denmark, Germany, Ireland, New Zealand, and other global leaders in this area. While the mix of these strategies appropriately varies by region and the status of how milk is produced in each of these individual jurisdictions, the approach is consistent. It is also important to understand, because of the short-lived nature of methane and the fact that the number of dairy cows in California is fewer today than it was in 2008, the amount of methane being produced each year is being offset by the methane leaving the atmosphere. We know methane is a short-lived pollutant with a 12.4-year atmospheric lifetime. This is why further reductions as we implement more digesters and other projects will help to offset the harmful impacts of carbon dioxide that will continue to increase and accumulate in our environment. If we can achieve the 40% reduction by 2030, it is also likely dairy production sector in California will be climate neutral and no longer adding to additional global warming. That is a tremendous accomplishment that we should not look past. Final slide. I want to thank everyone for the opportunity, and I'm going to ask my staff to put up on the chat for everyone a good policy piece that came out of UC Davis last year that will provide a good overall primer for those who would like to get more information about these topics I've discussed today. Thank you.
Awesome. Thank you, Michael. We now have Jay Jordan with the Leadership Council for Justice and Accountability, and they will be finishing off this section. Go ahead, Jay.
Thank you, Jeff. Appreciate it. Hi, everyone. I'm Jay Jordan with Leadership Council for Justice and Accountability. They, them, or she, her pronouns. I'm a policy coordinator at LCJA, which is a nonprofit organization based in Fresno. And I'm here to provide a perspective on this dairy methane issue that really prioritizes racial, climate, and environmental justice. And unfortunately, that means I'm going to have to sort of provide a little bit different of a perspective than what's been offered so far. Leadership Council works directly with low-income residents and communities of color in the San Joaquin and Eastern Coachella Valleys, including in several of California's biggest dairy counties, Kern, Tulare, Merced, and others. A lot of the folks that we work with disproportionately struggle with access to clean drinking water, air pollution, asthma, and other pollution and health issues. We advocate alongside community members who simply want to improve their quality of life. We agree that reducing short-lived climate pollutants is critical. It's been described by several people today why they're harmful. Where there's slight disagreement, especially when it comes to dairy methane, is how to address that problem. And a lot of us in the environmental justice and even sustainable agriculture communities are interested in how to approach the issue in a way that acknowledges the root cause of the problem. Next slide, please. And that root cause is about how dairy is produced in California. So really kind of going all the way back, this is a massive system of factory farms with thousands of cows packed onto a relatively small amount of land. And across the US, intense industry consolidation over the last 50+ years has led to very unsustainable practices, including large herd sizes, animal confinement, and flush-based liquefied manure storage systems where a significant amount of water is used to flush cow poop into these giant pools of manure, like the one shown on the bottom left of the screen. And the manure, as has been acknowledged today, seeps into groundwater, and that's not only in the lagoon, right? So it's mostly due actually to the over-application of that liquid as fertilizer, to the point where nitrates contaminate the groundwater and get into people's drinking water sources. And there was actually a representative monitoring report a couple of years ago that showed that all representative dairies in the Central Valley are polluting groundwater above the maximum contaminant level. So this is not an issue that's dealt with, like we heard earlier, double lining lagoons. It's something that's happening on the cropland that's adjacent to dairies, and is happening primarily in low-income communities of color. There's also air quality concerns. Dairy operations are a large source of ammonia, smog-forming volatile organic compounds, and a significant source of particulate matter. And residents that we work with living near dairies talk about not being able to go outside in the evening due to the flies, the strong odors, and other nuisances of living in those conditions. And this is all in addition to the climate impacts that I know we're focused on today. Next slide, please. So digesters and biogas, they've become the proposed solution of choice to the problem of methane, but they don't address the root cause because they're really based on continuing the same manure lagoon system, and they don't address these other environmental justice impacts, as was acknowledged previously. By providing an incentive for the production of massive amounts of dairy manure, these digesters actually encourage continued status quo dairy operations and also provide an incentive for them to expand, which exacerbates the drinking water and air pollution issues I just mentioned. From a climate perspective, digesters don't address most of the greenhouse gas emissions on the farm. And I want to echo here what Kevin Hamilton said earlier this morning about approaching this as a whole system and really looking at the whole dairy, including the enteric methane emissions from trucking, cows feed, and other operations on the dairy. And again, thinking about how some of these climate impacts can actually be made worse when we're incentivizing increasing a dairy herd size in order to produce manure. It becomes a perverse incentive to actually create more methane. And this isn't just speculative. We're already seeing firsthand how significant dairy herd size expansions are happening associated with digesters and biogas infrastructure. An existing dairy in Merced, for example, Merced County, recently initiated the process to more than double the size of its current herd from 4,070 cows to 9,128 cows, alongside the installation of a new digester. And this dairy received funds from CDFA's program in 2019. That's just one example. There's what feel like endless subsidies that are going towards this technology, which is very expensive and that ends up falling on the backs of taxpayers and ratepayers in the state. The dairy industry and the gas industry have received over $600 million of public funds through CDFA's DDRDP program, CPUC, CEC projects and grants, and the Aliso Canyon settlement. And that's in addition to low carbon fuel standard and other credit schemes. So really our public dollars are being spent on a very expensive technology with what feels like little end in sight. And the benefits of these technologies are being distorted by not fully accounting for the full range of emissions on the whole dairy, taking a systems approach, or by looking at the costs that are being externalized onto local community members. Part of the problem here is that there's no real air monitoring or even full evaluation of these emissions. The unintended impacts on communities that I discussed are not being fully considered and incorporated into CARB's analysis of the issue. Digesters also support continued industry consolidation, squeezing out small-scale and more sustainable pasture-based farms where they might be viable, and they benefit the gas and large-scale dairy industries only, not communities and not smaller-scale farmers. And lastly, burning dairy gas is not clean. It still emits the same pollutants as fossil gas. Pipelines can still leak, can be at risk of explosion, just like natural gas. So the question becomes why are we building new pipelines, new infrastructure, and extending the life of an industry that California is actively trying to phase out when it comes to a clean energy future? Next slide, please. So there are a lot of false promises and assumptions about dairy digesters, including that they're the main way to deal with methane from dairies, that they address the emissions from dairies, that they somehow help small dairies, and that the manure is just there and has always been there, so we might as well use it. And just focusing on that last point, factory farm dairies are supported by state and federal policy, including a regulatory environment that permits manure lagoons and unsustainable practices to continue despite their significant air and water quality impacts. The size and the scale of dairies in California is a result of policy decisions that have allowed these dairies to get as big as they have, causing concentrated pollution in lower income communities and communities of color, while small scale or pasture-based dairies collapse. And this is really, even if the number of cows have been going down, the actual concentration of cows has been going up. So the state's approach to SB 1383 so far has been to subsidize this expensive technology and really kind of try to make dairy biogas fit into our climate future using complex credit schemes and programs rather than actually deal head on with the root cause and directly reduce methane emissions from dairies at the source. During the scoping plan process and during the scoping plan period, CARB is going to be able to begin regulating dairy methane under provisions of 1383 and should be planning for that now. Disappointingly, CARB did not look into this in a meaningful way in their recent analysis report, and that's something that we really want to emphasize. Next slide, please. So in terms of recommendations, scenarios within the scoping plan shouldn't be incorporating the proliferation of biogas infrastructure. Investing in dairy biogas is a long-term commitment. The infrastructure is there for a long time. It's not a bridge solution or a bridge fuel as it's too often been mischaracterized. And we have to be looking towards zero emissions future, which does not include dairy biogas if we're going to take climate change seriously. The state should not also be relying on credit schemes and offsets that miscalculate the impacts of dairy biogas sourcing and allow ongoing pollution trading that harms communities of color and low-income communities. Scenarios should not assume any new or continued operation of dairy digesters because we need to prioritize direct methane reduction at the source in addition to co-pollutant reduction. And this includes detailed monitoring at individual dairies and public access to that information. And we should be funding real climate solutions that actually benefit local communities and small-scale farmers, not just large-scale industry. So just to kind of wrap up, the state should really be asking, how can we support dairies in a transition away from these manure lagoon-based systems and towards production practices that are aligned with climate goals, healthy ecosystems, and healthy communities? And CARB should be outlining policies to adopt in 2024 and beyond that regulate methane and incentivize the reduction of methane through agroecological alternatives that affirmatively improve the well-being of local communities and of the environment. So thank you for the opportunity to speak on this panel. I appreciate the time.
Awesome. Thank you so much, Jay, for your comments and presentation. And we are going to now move on to the landfills, organic waste, and renewable natural gas portion of today's workshop. So first up, we're going to be hearing from Clark Williams at CalRecycle, and he will discuss their agency's effort to divert organic waste and other activities in place that reduce methane emissions. After that, we'll hear from Antti Alexiades, and then we'll hear from Sam Wade at the RNG Coalition, as well as Karen Sung from the CPUC, and it will be concluded by Kevin Hamilton from the Central California Asthma Coalition. With that, I'll hand it over to Clark. So go ahead.
Thanks, Jeff. For those of you who I don't know, I'm a chief over CalRecycle's Analytical and Resources branch, and this is the fourth scoping plan I've had the opportunity to work on. As we work on this update to the scoping plan, it's imperative that we engage with stakeholders and that all voices are heard to ensure that community benefits are realized through the reduction in greenhouse gas emissions from the waste sector. I'm pleased to be here with you today, and I'm looking forward to hearing from you. Next slide. As you can see, over 50% of the material we landfill is organic. When landfill organic materials break down under anaerobic conditions, they generate methane, a short-lived climate pollutant. Despite significant efforts to date, the emissions from the waste sector have been increasing. Next slide. I find it helpful to review some of the actions taken under prior scoping plans to reduce short-lived climate pollutants from the sector. First, there was the adoption and implementation of the landfill methane regulation, which CARB staff will talk about in the next presentation. Second up, we had efforts to address mandatory commercial recycling. Historically, nearly 3/4 of California's waste stream was from the commercial sector. The regulations adopted to address commercial recycling took place in 2012 and have been achieving greenhouse gas emission reductions by diverting commercial solid waste from landfill disposal. Significant work has also gone into the development of emission reduction factors to quantify the climate benefits of alternatives to landfill disposal, such as recycling, composting, and digestion. For example, a recently developed quantification method can be used to determine the emission reductions achieved from climate positive landscaping. Climate positive landscaping are projects in urban areas that transform traditional turf landscapes into more sustainable landscapes, which results in greenhouse gas emission reductions. The development of emission reduction factors has supported the utilization of cap and trade proceeds for grants and loans to build recycling infrastructure that reduce short-lived climate pollutants. CalRecycle's approach to each of these actions have benefited greatly from extensive public engagement via workshops, meetings, and community dialogue. As a department, we're looking forward to engaging extensively with everyone on both the development and implementation of this current update. Next slide. Senate Bill 1383 represents the most significant effort underway throughout the state to reduce greenhouse gas emissions from the waste sector. The baseline for the ambitious goals you see on the slide is 2014, when 23 million tons of organic waste were disposed in California. With the regulations not going into effect until 2022, it's not terribly surprising that we did not achieve the 50% goal, as we disposed more than the 11.5 million tons of organics allowed. Substantial progress is needed for us to make headwinds towards the 2025 goal. Next slide. After Senate Bill 1383 was passed in 2016, CalRecycle initiated a robust 2-year informal rulemaking process to ensure stakeholders could provide as much feedback as possible early in the development of the regulations. As I mentioned, these regulations go into effect January 1, the upcoming year, and I'd really like to acknowledge all the hard work taking place in communities and jurisdictions throughout the state to get the programs in place that are needed to achieve these ambitious goals. The events of the last few weeks, from hurricanes to fires, have certainly shown yet another spotlight on why these efforts to reduce shore-level climate pollutants from the sector are so critical. Next slide. In addition to reducing shore-level climate pollutants, achieving these goals has a number of other benefits. Creation of over 11,000 permanent jobs, annual production of over 800,000 tons of compost, which when applied can help improve soil health, and the annual production of over 25 million gallons of renewable fuels. Next slide. This legislation required CalRecycle, in consultation with CARB staff, to analyze the progress that has been made toward achieving our organic waste reduction goals. Four key findings came out of the analysis related to infrastructure, collection, permitting, and procurement. First, despite growth in infrastructure over the past few years, significant additional infrastructure expansion is needed to meet the disposal reduction goals. Second, mandatory organics collection programs are critical to help attract the private investment needed to expand organics processing infrastructure. Third, California's permitting and regulatory requirements are necessary to protect human health and the environment and to address community concerns regarding new and expanded facilities. And fourth, the regulatory requirements to procure products such as compost and renewable natural gas are necessary to develop markets and are essential for achieving the goals. Next slide. There are a number of activities such as source reduction, recycling, food recovery, biomass, rendering, animal feed that constitute a reduction in landfill disposal under the 1383 regulations. Here we can see both the available and needed compost, anaerobic digestion, chip and grind capacity to meet the goal. It's important to note that the SB 1383 regulations do not dictate which alternatives to landfill disposal must be utilized. Jurisdictions and communities throughout the state have the flexibility to design their programs to utilize landfill alternatives that work best for their community. Communities throughout the state are currently assessing organics recycling capacity and planning for additional capacity when needed. Through this planning process, I'm looking forward to the opportunity to look at capacity expansion and opportunities to maximize community benefits. Next slide. As the planning for additional organics recycling capacity takes place, it is imperative that environmental justice issues are addressed head on. We need to ensure that every California enjoys equitable protection from environmental harm, regardless of age, culture, ethnicity, gender, race, income, or location. The SB 1383 regulations facilitate this with the requirements listed here on the slide. As a department, we recognize how important it is to engage with all stakeholders in this effort and to ensure that all voices are heard through authentic and consistent engagement. There's not one right organics recycling technology or process. The appropriate type or suite of organics recycling technologies must be determined by understanding and considering the needs of individual communities. Next slide. One of the organics recycling processes that enjoys broad-based support is edible food recovery. Over 4.9 million Californians are food insecure, which means that roughly 1 in 8 people and 1 in 5 children don't have sufficient food. To make matters worse, rates of food insecurity have doubled or tripled during the present pandemic in some parts of the state. The regulations adopted by the department in response to SB 1383 requires the recovery of edible food to feed people. To achieve this goal, commercial edible food generators will be required to donate the maximum amount of excess edible food. And jurisdictions are required to assess capacity to recover edible food and work to expand it where needed. CalRecycle's Food Waste Prevention and Rescue Grant Program has awarded $23 million to date to 77 projects to help expand edible food recovery capacity, but certainly more is still needed. Next slide. To date, the department has provided close to $144 million in cap and trade proceeds to expand the state's recycling infrastructure. Ensuring these investments realize community benefits has been and continues to be a priority for us. For example, grants are structured to reward projects that create high quality jobs and that provide job training, resulting in industry recognized certifications. The grants also incentivize development of community benefit agreements. These are agreements between a grant applicant and groups representing local residents. The agreements establish ongoing communication processes, specific actions to address facility impacts, monitoring and reporting protocols, and other discrete community benefits. CalRecycle has also developed a community composting for green spaces grant program that was designed to promote community-based solutions to organic material recycling in disadvantaged and low-income communities. So far, 120 community compost sites are being supported through the program with services delivered in a multitude of languages. Next slide. As we work together on this update and planning to get to carbon neutrality, a few high-level concepts stand out to me. One, how do we take ownership of California's waste and use it as a resource to build a circular economy? Two, how do we utilize waste, or what we've historically landfilled, as manufacturing feedstocks to reduce upstream emissions associated with resource extraction and processing? CalRecycle is standing up a new Office of Innovation to help aid the transition to a circular economy and bring a renewed focus to market development and remanufacturing. Next slide. Thank you for making the time to be here with us today. I'm really looking forward to your thoughts and ideas for the sector as we work together to chart a path to carbon neutrality. Back to you, Jeff.
Yeah, thank you, Clark. Our next presentation for this section of the workshop is going to be from Anthi Alexiadis at CARB, and she is in the short-lived climate pollutant policy section. So Anthi, take it away.
Thanks, Jeff, and thank you, Clark, as well. Hi, everyone. I'm Anthi Alexiadis in CARB's short-lived climate pollutant policy section. So landfills are the second largest contributor to the statewide methane inventory. And I want to make sure that everyone realizes this is in spite of the fact that about 95% of all the waste that's been disposed in the state has been deposited in a landfill that's equipped with a gas collection and control system. And although these collection systems are designed to capture the landfill gas that's generated each day as waste decomposes, we know that a portion of the gas escapes into the atmosphere as fugitive methane, accounting for over 20% of methane emissions in the state. Next slide, please. Using CARB's greenhouse gas inventory methodology for landfills, future methane emissions can be estimated based on the amount of organic waste disposal that's expected in each year. First, note that landfill methane emissions have increased steadily since 2013 by about 0.1 million metric tons of carbon dioxide equivalent per year, as shown in the solid portion of the blue line to the left of the figure. While our capacity to divert waste from landfilling to organic recycling facilities has grown over this time frame, the gains have unfortunately been outpaced by increases in waste generation. The yellow dashed line reflects the emissions that would occur if the state is able to achieve 75% disposal reduction target of SB 1383 by 2025 and maintain that level of disposal in subsequent years. So achieving that 75% target would mean that less than 6 million short tons of organic waste is landfilled in 2025 and thereafter, compared to the 23 million tons that were disposed in 2014. This level of disposal would bring annual landfill methane emissions below the 2013 baseline by 2030 and achieve a reduction of about 1.2 million metric tons of carbon dioxide equivalent by 2045. However, preliminary estimates show that the state is on track to reduce organic waste disposal by only 50% relative to 2014. The blue dashed line shows future emissions using the statewide organics recycling capacity that was anticipated in CalRecycle's 2020 analysis of progress towards the SB 1383 waste reduction goals that Clark just mentioned. This potential capacity shortfall would mean that emissions remain above the 2013 baseline until 2035, and by 2045, less than 0.2 million metric tons reduction from the baseline would be achieved. Next slide, please. So decomposition in landfills occurs slowly over the course of more than 30 years. This figure shows how the emissions from landfilling 1 ton of organic waste in 2025 compare to the emissions of diverting that waste to an aerobic compost facility. Now, I want to use this slide to illustrate a quick clarifying point on some terminology. We often hear people refer to bioproducts like renewable natural gas as carbon negative. And in the context of our annual greenhouse gas inventory, which is used to track progress towards our targets, the term carbon negative doesn't apply here. In programs that use a life cycle carbon accounting framework, like the Low Carbon Fuel Standard, we sum up the cumulative emissions that would have resulted from landfilling this ton of waste over time, as shown by the yellow area in the figure. And we include these avoided emissions in the calculation of a product's carbon intensity. In our annual inventory accounting system, we can see in year 1 that the emissions from the diversion process may be greater than the landfill emissions that would have occurred in the first year. But over the lifetime of waste decomposition, this single ton of waste continues to emit significantly more methane. So the key point here is that the long lifetime of waste degradation in landfills means that those near-term diversion efforts are critical to avoid locking in these future methane emissions. Next slide, please. So while reducing organic waste disposal is the most effective means of achieving significant permanent reductions in waste sector methane, it's clear that we'll also need to address the emissions from waste already in place in landfills. The remaining degradable carbon, shown here in blue, is the amount of waste with the potential to generate methane that's been deposited in landfills over time and hasn't yet broken down. So that quantity is always in flux, right? It increases each day as new waste is deposited into a landfill, and it decreases as a fraction of that carbon biodegrades and is converted to carbon dioxide and methane. So as this figure shows, the amount of carbon remaining in landfills and therefore contributing to methane emissions in 2019 was over 20 times larger than the amount added in that year. So what this illustrates is that even if we were able to entirely phase out landfilling of organic waste today, the existing waste in place at landfills would continue to generate methane for decades into the future. Next slide, please. So the landfill methane regulation is our primary mechanism for controlling emissions from waste in place. This regulation established the most stringent threshold in the nation for landfills to install control systems and includes comprehensive monitoring provisions to minimize methane emissions. The set of strategies and technologies required under the LMR is estimated to capture at least 75% of landfill gas and reduce emissions by nearly 2 million metric tons of carbon dioxide equivalent per year. However, landfill emissions are highly variable, seasonally and spatially, both within a landfill and between landfills. So it's difficult to quantify methane emissions directly and on a continuous basis. This in turn makes it difficult to demonstrate improvements that can increase the efficiency of capture systems and reduce methane emissions. So as methane monitoring technology improves, CARB's methane research program is focused on leveraging these capabilities to identify new technologies and operational practices that can reliably reduce emissions at landfills, as well as improve quantification of emissions and better understand their variability, and to detect large leaks so they can be mitigated promptly by facility operators. Next slide, please. So we're looking forward to receiving your feedback on these questions, which will help us set methane reduction targets for the waste sector beyond 2030 and identify potential strategies to achieve them. Thank you very much.
Awesome. Thank you so much, Audrey. That was great. We're now going to jump over to Sam Wade at the RNG Coalition to provide an industry trade group perspective on renewable natural gas use. So Sam, when you're ready, go ahead.
Yeah, thanks a lot, Jeff. Pleasure to be with everybody today. I'm Sam Wade. I'm the Director of Public Policy for the Coalition for Renewable Natural Gas. We're the national trade association for the industry, but we have our roots in California and still spend a lot of time in the state. On the next slide, actually next few slides, I have a little bit about us, starting with the fact that we're a Big Tent organization. We advocate really across the entire RNG supply chain, and we're feedstock agnostic, end use agnostic, and really do attempt to be sort of a clearinghouse for information about the renewable natural gas product. And our members make 98% plus of the RNG supply in North America today. And on the next slide, there's some of our leadership members, and the following slide has some of our general members, just to give you a sense of who's involved and the scope of the organization. And then the last slide on the membership side of things has our academic members and advisors. And this has been really critical to shaping our long-run view of how we can evolve as an industry and how we can contribute toward the state's GHG goals. So just wanted to highlight the fact that we're getting advice from these institutions. Next slide, please. And they've, drawn to our attention the important messages that have already been covered today. For example, the fact that abating methane from organic waste remains a critical climate strategy, both globally and in California. And the IPCC in the recent Code Red report, explicitly calls out methane capture and recovery from solid waste management as a very beneficial activity that can improve our ability to respond to global climate change and buy us some time, essentially, and also at the same time make some improvements in local air quality benefits by reducing surface level ozone. So these are some direct quotes from that report shown here. CARB's known about this for a long time, as you heard today already. And in fact, the Short-Lived Climate Pollutant Reduction Plan produced in 2017 laid out these strategies we've been discussing today. And as you already heard from CalRecycle and CARB, on my next slide, I just pulled some quotes from the recent reports saying, while we're making progress, we're not all the way there. And in fact, we're perhaps more behind on the organic waste from the municipal solid waste stream side of things than we are on the dairy waste side of things. And the RNG industry stands ready to keep helping to achieve these goals. And we agree that the economics of RNG production will be a key driver in ensuring that the necessary capacity is established to process these wastes in a way that minimizes methane. So next slide, please. The RNG industry has grown a lot in the last 10 years, primarily as the result of supported policies from the US EPA and from CARB. In 2011, we had 30 RNG projects operational in North America, and now we have over 188, and many more coming. And that's basically in response to the recognition that climate change will be a driver of how these wastes should be dealt with in the future, and that leading jurisdictions like California have put in place the proper incentive structure to motivate action. And I think you can see just from the numbers here that there's certainly a lot of attention paid to building projects in California, especially in the dairy space, as Michael already touched on. Next slide, please. So I think folks often say, well, how much RNG can we make from this organic waste material, and how much can that contribute to our climate goals by displacing conventional fossil gas? There's certainly been a lot of studies done on that. They produce a wide variety of results depending on which feedstocks are included and basically how conservative you want to be about certain assumptions. And so the range is maybe between 4% at the current level of incentives or slightly diminished level of incentives relative to where we are today, all the way up to maybe around 28 to 30% of total gas demand. So the point here really is that while RNG can be a very helpful strategy, especially for its methane benefits, it does not fully displace the conventional gas sector. It needs to be coupled with other opportunities like efficiency and electrification and reducing leaks from the gas system to maximize the long-run carbon neutrality in space, which is, of course, where the state needs to head. I'd also say that an important part about this work is really to think about sort of the end use opportunity here being flexible, right? If we can put this gas into the pipeline system, we can divert it to any end use that we might deem to be essential to use the gas in the future. It could be transportation, it could be the use in buildings in the commercial and residential sector, or it could be in power generation or in industrial activities. And so this slide in the portion here that shows the percent of total demand, current demand today that the RNG could serve. Obviously, if we're successful in electrifying one of these sectors completely, it won't be necessary to be used in those applications. But I think it's highly unlikely that we're able to do that for all sectors, which is why creating a robust RNG supply today to reduce methane and also to be ready for this challenge that many of these sectors are going to face in decarbonizing is a nice balanced solution to take. Next slide, please. So luckily, this is beginning to happen in transportation, for example. So because of CARB's low carbon fuel standard, we've now achieved a 98% blend rate in transportation natural gas vehicles in Q1 of 2021. So that means we've pushed out all the fossil gas out of that sector and are now only using renewable natural gas in vehicles pretty much. And we need to see that type of activity happen in every application in my mind. And as gas demand goes down over time and renewable supply increases, eventually we do expect those things to approach each other, but we're nowhere near that across the entire gas space today. Next slide, please. So Antti and others have already sort of touched on this a bit. In CARB's low carbon fuel standard, there's an extensive life cycle analysis that's done for each RNG project. And many of the projects are found to be carbon negative. For example, almost all the dairy projects are. The organic waste diversion projects are certainly also carbon negative because they avoid that remaining landfill methane emissions that Antti touched on. And many of the landfills are still much better than fossil gas and could be improved over time if their capture efficiencies could be increased, or if their leakage rates could be reduced during upgrading, et cetera. So there are opportunities to make RNG from the organic waste space that really span the gamut of technologies here. And you kind of have to take advantage of all of those to deal both with the waste in place and with the new waste that you've diverted to dedicated AD facilities. Next slide, please. So we think that the concepts that CARB has already pioneered within the LCFS should be deployed in other sectors as well. The first and most important concept is full life cycle analysis on how the RNG is made, moved to end market, and consumed. Using that life cycle metric, can address common concerns and criticisms about RNG, including, how it's made, ensuring that there aren't carbon intensive inputs on the feedstock side, ensuring that methane leakage is minimized to basically give more incentive when leakage rates are lower, and to minimize transportation distances and new gas infrastructure to ensure that the projects that are being built think about those issues and try and minimize embedded emissions and transport distance to reduce total GHGs across the life cycle. And these life cycle analysis tools are great, but they can keep getting better over time. Antti touched on sort of the avoided methane benefits from displacing landfill gas from organics diversion. We feel like those benefits are currently undercounted in the existing tools and they could be improved. And similarly on the nitrogen cycle, I believe Jay mentioned that it's important to look at nitrogen from these facilities from an air quality perspective, from a water quality perspective, and from a GHG perspective. So better recognizing the GHG benefits of certain digestate-based fertilizers that can be made could allow us to tap other feedstocks like poultry waste and really better recognize the agricultural phase benefits of the digestate. So we'd love to see CARB and others look at that moving forward. Next slide, please. From an air quality perspective, we think it's clear that pipeline injection or fuel cell application of this gas, this biogas, is preferable because as you upgrade the gas, you remove contaminants and therefore you get better end-use combustion performance. And a lot of times you displace either conventional gas or diesel, as other commenters have already pointed to today. And that is best for the communities living near these projects. And of course, that's a critical concern here. So we do think that putting the gas in the pipeline rather than flaring it or using it in an inefficient genset on site will be preferable from an air quality perspective in most cases. And this study from US EPA and CARB basically lays that out if folks are interested. Next slide, please. So I'd like to point out that because we have a national focus, we're seeing California leadership impact both the industry, and I showed a map of how many new facilities have been built as a result of CARB policy, but also we're seeing other states and regions adopting similar policy. And that therefore, concerns about why are we buying gas from out of state, I think are a bit misunderstood. When we build projects out of state, the industry gets a toehold in these jurisdictions and then can advocate for policies similar to California in those locations. And as a result, the idea of a low carbon fuel standard type program is spreading across the country. And there's going to be a lot of competition for renewable natural gas moving forward, especially in the transportation space. So this map just sort of shows where that activity is occurring. Next slide, please. So, folks have sort of touched on the fact that we have pretty good incentives for thinking about making this gas and using it in the transportation sector, and a little bit of similar incentives on the power side. But we really haven't attempted to put any of the gas toward utility procurement in buildings or in the industrial sector, the non-core gas customers. And we think that's essential moving forward because those sectors are a much larger source of gas demand today and are a natural home for RNG as it continues to scale. So I know Karen from PSC is going to talk about that after me, but we'd like to emphasize just the size of the non-core, the industrial applications and the residential commercial applications is just dramatically larger than the transportation application, which has already been sort of the model to build off of. Next slide, please. And the idea of RNG procurement, for general gas utility customer use is spreading, and really there's other states outside of California who've already begun to pioneer that. So in Oregon, we have Senate Bill 98, which is already fully implemented, and the Oregon gas utilities are procuring the RNG now, as well as in leading Canadian provinces like British Columbia and Quebec. And so, California, while we're certainly a leader, we're working with these other North American partners and the Pacific Coast Collaborative and the Western Climate Initiative, and they're a little ahead of us, I would say, on gas utility procurement of RNG. But we're certainly not the only ones taking action here, and if everyone moves together, we can build a nice integrated system that hopefully allows folks to maximize methane reduction from making the renewable gases. Next slide, please. So the last couple points I want to make are basically that all studies that look at deep decarbonization, like we're talking about in this scoping plan, achieving carbon neutrality or going past it to continue to pull emissions out of the atmosphere and get us, to a very stable climate, see a role for RNG. But many folks disagree about which sector is going to need it the most over time. And so I think the answer, therefore, is to not choose a sector yet, but to offer strong incentives for the reduction of methane today. As I'll touch on the next slide. Can you guys give me the next slide, please? So we should try and reduce methane today by building the projects as fast as possible. And to do that, we have to have procurement incentives and demand pulls from other sectors besides transportation. And then the midterm, we need to begin to focus the RNG resource to the hard to decarbonize sectors, or the sectors that can't easily be electrified is another way of thinking about it. And then the long term, we need to manage the transition of those RNG production facilities, potentially to produce hydrogen and couple that hydrogen with CCS production or CCS sequestration. And what that would allow is carbon negative performance from all RNG feedstocks, including woody waste and other things, which we did touch on a little bit today. And by walking in this way toward success in the RNG space, I think we will ensure that the investments that are made are not wasted or stranded in any way. And I think that's of concern to project developers when they hear discussions around how the gas sector will evolve over time. It does create some some confusion or some tension. And when there's incentives in one sector and not in another sector, it's very confusing for investors, especially if the incentives that were so strong in one sector are slowly like being pulled away in the case of transportation, for example. So that's how the industry is viewing the correct long-term path for the state's take. And I encourage folks in the scope and plan cycle to really try and work towards something like this framework. So last slide here, just have some conclusions. I mean, basically, many opportunities still exist to deploy RNG across all sectors, and it's pretty essential that we do that to meet our methane reduction goals and to begin the decarbonization of the gas sector. The LCFS is a proven model, and the life cycle analysis in that program should be extended to other programs. And the RNG production capacity expansion that Clark and others, called for under 1383 on the organic waste diversion side, will not happen without really additional policy support. So timely California leadership in this plan cycle, continuing to build across all sectors with our success and the concepts that have worked, will be recognized by other jurisdictions and will help us achieve, the global outcome that we need to see with respect to methane. So I'll stop there. Thanks a lot.
Awesome. Thank you so much for that presentation, Sam. We have 2 more presentations left in this workshop, and then we'll move on to some public comments. So we have Karen Sung from the California Public Utilities Commission, and she will be presenting on what the CPUC has been discussing as opportunities for moving RNG outside of transportation and for alternative energy uses. So Karen, take it away whenever you're ready.
Thank you very much. So my name is Karen Sung. I'm a senior energy analyst. Next slide, please. So today I'll be going over some of the policies that have led us to inject renewable gas into our pipelines. First, the standardized pipeline interconnection policies. Second, a voluntary renewable natural gas tariff. And finally, the SB 1440 implementation, which is really the renewable gas procurement staff proposal. Next slide, please. First, we have standardized pipeline interconnection policies. We released 2 decisions last year. One that standardizes gas quality. So gas quality injected into our pipelines, regardless of whether you're in PG&E, SoCalGas, or SDG&E, or Southwest Gas Territory, you can expect the same requirements to purify your gas before injecting it into the pipelines. The second decision was a standard contract for any developer who wants to sign or inject into California statewide gas IOUs, investor-owned utilities. We also increased biomethane interconnection incentives, an additional $40 million. So it was originally 40. Next slide, please. So the voluntary renewable natural gas tariff is something that CPUC approved. It's an application from SoCalGas and SDG&E to provide their customers an option, a voluntary opt-in option to pay for renewable gas. So if you want a set amount of your gas supply into your home to be renewable gas, you can pay extra for that amount. And this program is temporarily on hold while we move forward in SB 1440 procurement. But before we move on, I want to highlight that this program allows for 50% to provide an environmental benefit in California, that's PU code 651, but also the additional 50% could come from out-of-state sources. Next slide, please. So here I'm going to dig into the details of how we came up with our procurement plan and how we can best support other state agencies. We worked with 9 other state agencies and we sought their feedback on how best to tailor it and ensure we meet our GHG goals, we meet our declining fossil goals, and also how to make sure we best ensure environmental justice. Next slide, please. So SB 1440 is a bill that passed in 2018 that tells us to consider, with consultation of California Air Resources Board, to adopt a procurement plan. So we worked very closely with CARB, took their feedback, and worked as much as possible towards a joint effort. And we got some pushback on whether consider means actually adopt, but if you move to section B, it says if commission adopts. So the legislation is clear on our authority to move forward with a procurement plan. Next slide, please. So you've already seen this slide in slightly different fonts and colors, but livestock emissions is the largest source of methane in California, 54% from livestock between manure management and enteric fermentation. But we've already heard from earlier presenters that there are plans to work on that. That we've also heard earlier that there are plans to reduce methane leaks from the gas distribution and transmission sector. And if you look at the pie and you add up how much is transmission for residential, transmission for industrial, and the oil and gas production, it's still less than landfills. However, landfills are regulated. We just heard about how there are efforts to try to constrain how much leakage there is, and yet there's still massive amounts of organic waste decomposing and generating methane in landfills. So we figured that would be the best place for us to focus on. Next slide, please. So our short-term goals are to support CalRecycle. CalRecycle just presented how they are short infrastructure for their 2025 goals. And if you focus on the last line of this table, you see they have anticipated capacity of 10 million, but the needed capacity to meet their 75% reduction organic waste diversion goal, it needs to be 18 million. So the difference here is an 8 million ton shortfall of infrastructure to divert all the organic waste that we need to hit our 2025 goals. So that's where we step in. We will seek to support organic waste diversion to wastewater treatment plants and to standalone digesters. I heard a public comment earlier about diverting to organic waste or wastewater treatment plants, and this is basically it. Next slide, please. So we have existing 153 wastewater treatment plants with existing anaerobic digesters. Just to reiterate environmental justice here, these wastewater treatment plants are required to capture and flare or use, same with landfills, and yet burning raw biogas, as Jay Jordan said earlier, is harmful to the local community. And a lot of these wastewater treatment plants and landfills are located in disadvantaged communities. So what we want to make sure is that these wastewater treatment plants are purifying their biogas into and then injecting it into pipelines so that we don't harm the local community. So there are 153 existing, so this is low-hanging fruit, existing infrastructure that we can modify and increase organic waste capacity. There are also 9 standalone digesters, 8 of which we expect growing and expanded capacity in the next few years. Next slide, please. And our medium-term targets, which we will revisit in 2025 and hope to incorporate CARB's SLCP scoping plan update, that is to eventually procure a set volume of methane gas. And we picked this number from the original 2017 scoping plan. If we are successful in organic waste diversion, we can divert 4 million metric tons of CO2 equivalent per year. And that converts back calculated to 75.5 million tons of MMBTU of biomethane, or 72.8 BCF. That equates to about 12% of core gas demand in California. So this procurement plan is to procure for our core customers because that's where we have our jurisdiction, that we can direct the gas IOUs to procure from these wastewater treatment plants and standalone digesters. We also excluded dairy biomethane in our medium-term targets. We are awaiting additional feedback from CARB. We do know that based on public feedback, there is strong opposition to any livestock procurement, and we also know that there is a limited supply for LCFS. I would like CARB to include or at least expand the LCFS market to include beyond just transportation. So we also have feedback that our procurement should be resource neutral, or feedstock neutral. So this is all up in the air as we try to solidify our actual procurement plan. Next slide, please. So part of our medium-term targets is expanding the feedstocks, and some feedstocks that we discussed in the staff proposal is forest woody biomass and agricultural waste. There's currently a ban on open ag burning in San Joaquin Valley because of the air quality implications. And forest woody biomass, we would specifically be targeting the forest thinning that we have already established between the state and also U.S. Forest Service. So what we want to do here is try to prevent additional wildfires through projects that could support the techniques that CAL FIRE is doing. So we worked with CAL FIRE on this. We also worked with Natural Resources Agency. We got a lot of feedback because wildfires are burning through our entire carbon budget. And so whatever we can do, if we can expand facilities that can generate woody biomass or gas from woody biomass and also prevent wildfires, I think this would be one of the best options. Otherwise, or agricultural waste, there's no place for it. It's just collecting because it can't be burned. If we put it into a gasification or pyrolysis plant, we can at least process it, create biochar, and biochar would effectively sequester carbon, depending on feedstock, for up to 100 years. It's a lot more stable than compost or any other form of carbon sequestration. Next slide, please. We were instructed under SB 1440 to develop a cost effectiveness test. We want to make sure that the ratepayers are not disproportionately burdened with this procurement plan. So we need to find a way that takes into consideration low income users and also take into consideration just how much the prices will increase. So we have a joint IOU analysis that will establish a cost effectiveness test, and we are working with the gas IOUs on this. There's the biomethane procurement plan, which is an economic analysis of how it will impact ratepayers and everything else listed here. Finally, we have a tiered approval rating, and this is not a cost effectiveness test. I want to be clear that the tiered prices are merely procedural methods for us to review every single contract that goes through so that we can check for co-benefits, we can check for the benefits for environmental justice and a variety of issues on whether a small producer or large producer should charge more or less. Next slide, please. And we have an environmental justice and social justice action plan. We have 9 goals. I've only quoted one here, but it was one that I kept in mind as we were developing this entire plan. And we used the environmental justice and social, or the ESJ action plan in developing additional recommendations that help tailor it and make sure that local communities have improved lives as opposed to overburdened lives despite our attempts at reducing GHGs. Next slide, please. So there's a lot here, and this isn't even all of it, but I'm going to try to go through this quickly. We have, we don't want trucks to be running on diesel. So any facility that chooses to divert organic waste and those facilities will have less trucking. Landfills will have less trucking, but wastewater treatment plants will have more trucking. So we want to make sure that those trucks are running on either low carbon, that's renewable gas, or electric vehicles or hydrogen vehicles, so that the local community does not experience the pollution from these diesel trucks. Another thing is we want to cap all on-site gas combustion. So wastewater treatment plants and landfills currently combust raw biogas, which we, based on a CEC study, shows that it increases local air pollution. So we want to do as much as possible without undermining other state programs to cap combustion. If these facilities are already purifying their biogas to biomethane and injecting it into the pipelines, then they are capable of using that biomethane to use fuel cell electricity, and fuel cells are more efficient. They are 30% more efficient than combustion generation. So there's this added benefit of this limited resource. We don't want any additional new resources. We don't want purpose-grown crops or anything else. This is specifically dealing with our waste streams. Since our waste streams are limited in production, we want, and hopefully decreasing with other plans, we want to be able to generate more electricity from it. So I think there's this added benefit of capping the on-site combustion generation, but then using fuel cells instead, and that would help benefit the communities near these facilities. We want to promote carbon capture and storage based on feedback, potentially use as well. And also the waste byproduct, the digestate, can be converted into biochar. That process is pyrolysis, which according to EPA, destroys 90% of the forever chemicals, PFAS, which is very harmful to human health. So there are additional benefits to biochar that can be used, and either a soil amendment, so it closes the circular economy, or it could be used in some cement or asphalt. So there are other uses for biochar, and that way we have a complete circular economy, or at least a regenerative economy. And we want to require that the gas IOUs procure woody biomass. So they start a pilot project specifically for woody biomass to help prevent wildfires, because black carbon is also, as discussed earlier and in public comment, something that's seriously under consideration. Even though it's not necessarily part of CARB's scoping plan, we think that there's this added benefit. And if CARB decides to include wildfires, then we would like to be included in this effort. Next slide, please. Just for everyone's knowledge, there are modifications pending. We are incorporating all public comment and also CARB's feedback. So this was just a preliminary open discussion on how best to procure renewable gas. Thank you. Next slide, final slide. It's my contact information. Thank you, Jeff.
Yeah, thank you so much for that great presentation, Karen. We're now going to move on to our final talker for this panel. And so that is going to be Kevin Hamilton from the Central California Asthma Collaborative. So unmute yourself, Kevin, turn on your camera and go ahead. Kevin, are you still on the webinar? Okay.
Jay Jordan is actually speaking for the Environmental Justice Advisory Committee on this issue.
Let me hop in here. Kevin, I believe Jay already spoke a little earlier on dairies, and so we do have some time available for you if you'd like to also give some additional perspectives on
Sure.
dairies, organic waste, or RNG.
Oh, absolutely. I had mentioned that I was going to hold it and just take my space in the EJAC public comment section, but I'm fine with doing it now. That's fine. Thank you. Thanks for that courtesy. I appreciate it, everyone. Yeah, so with regard to dairy digesters, and as I referenced in my earlier comments on HFC's black carbon and methane from oil and gas, we have to treat these things as a system. And if we just reduce emissions in one part of the system, we can often accidentally increase emissions or leave them behind in other parts of the system. And this is a perfect example of that. When we first looked at dairy digesters back 15 years ago or so, and we were really thinking about this as being a great potential solution for not just methane, but also the particulate emissions from the dairy. And our thoughts back then is that this methane would be used to create electricity, and certainly, that bears a burden of some particulate matter, but that could be offset if the dairy had first access to potentially and hopefully free electricity, or certainly at wholesale rates, and then would move to, with incentives, electrify all the massive diesel engines on the dairy that it requires to run things like milking carousels and pumps. And so there's a lot of those. And then what we found is, in fact, that because of the CPUC regulations and the IOUs, and the people who own the digesters, suddenly this energy had to be sent back to them first, and then if the farmer wanted to buy it back for those kinds of things, they could. And that still stands today. So, You know, now we're talking about moving to using this same gas for transportation fuel for a truck fleet that doesn't actually exist. I won't argue that there's CNG trucks on the road, but they're by no means the future. And no longer are we really feeling like we need this bridge fuel. If you look at CARB's truck and bus rule coming up, the new advanced clean freight rule, as we move into 15% purchase for EV vehicles, including heavy duty, and at the HVIP program funding, again, only heavy duty electric, you know, it's pretty obvious what the writing on the wall is with this whole thing. So there are alternative practices for this. We still believe that the original idea is valid, that if the dairy farmers are going to be saddled with this thing, that it should benefit them greatly. Certainly getting off the radar on methane will benefit them, but if they could get free electricity out of this and eliminate all the black carbon and other particulates coming from those big motors with big icy engines on the dairy and vehicles on the dairy, and get that for free or at wholesale prices, I'm sure they'd be pretty happy about that. I'm not positive because I haven't asked them all, but I've got a feeling that would work on a lot of levels, because we'd reduce the exposure to them and their workers and their animals, but also the crops around them and the communities that are around them that are mainly, again, this vulnerable group of folks who tend to live in substandard housing that leaks like a sieve, and so these emissions are coming through there. So in our single-mindedness to address this one short-lived climate pollutant, which is a critical issue, there's no doubt about that, we have chosen this particular vehicle, pun intended, to move forward with as the solution. And it quite honestly just doesn't pass the smell test. Again, another pun, I can't help it, sorry. And so, yeah, I think again we need to move past this. We need to start thinking in terms of what does the whole operation look like. Landfills in general are using it to create energy to run the landfills. Water plants are doing the same thing. So, you know, yet we've got this group who for some reason is shut out of doing that because they're not run by a local government agency. And that's never made sense to me. I'm not sure why it makes sense to them. And I certainly don't understand why it makes sense to the agency. The only people I can understand why it makes sense to are people who own the facility, keeping in mind the digester is not owned by the dairy, it's owned by this company that makes money from it. And the utilities, the IOUs, who are making money from this energy being transmitted, so across their power lines. So it's a win-win for all of them. You could argue that the methane that's reduced is a win as well, but it's by no means all the methane. It's about a third, right? We know that. The cows are everywhere. You know, methane's produced in the free stalls. You know, with the water problem, the idea that we're going to actually rinse these stalls 3 or 4 times a day in order to maximize the control of that manure is pretty crazy. Even recycling the water at 110 degrees, 115 degrees, there's got to be a lot of water loss to evaporation. So that's just tough. But, and then outside those freestall areas, again, you know, the cows keep producing gas, it's just the way it is. Industry did a good job with the whole cow fart gag, burps and farts, but, you know, that's the reality of the situation. And again, I mentioned emissions coming off the facility from other sources are still there. So, and as these sources become larger, those same emissions grow with them. So, I don't know that there's any way to change this now. CARB and CDFA and the state have invested so much money in it. I can't believe it. And, you know, we've got, you know, one operation that's got, I think now 12, maybe up to 14 dairies running product into it. So I don't know how you turn around from this, but I think it's a disaster just waiting to happen. And I will go back to the other problem we talked about. Gas is being transmitted through lines that are the principal source of methane in the inventory, those natural gas lines. And so we're just adding to that yet again, and then transporting this fuel in trucks that those tanks could potentially leak, or certainly when they're hooked up and the fuel is dumped wherever it ends up, if it's not put into the pipeline. And again, all those places tend to be in one community, and that's one that is poor and doesn't have a lot of decision making about whether or not those facilities are built next to them, whether it's the dairy or the local storage system or the end use of the vehicles. So to me, you know, this is a Band-Aid, and when it gets ripped off, it's not going to be good. So thank you very much for your time. I appreciate that.
Thank you, Kevin. So we're now going to start moving to a public comment portion of the workshop. We're going to first give the members of the Environmental Justice Advisory Committee a chance to speak. So we have a 15-minute period allotted for them, followed by public comments. Trish, are there any hands raised from EJ Advisory Committee members?
Hi, Jeff. Yes, I see 2 so far. I'm going to start with Dr. Catherine Garupa-White, followed up by Paulina Torres. You should be able to unmute yourself, Catherine, and begin your comment.
Thank you, Trish. This is Catherine Garupa-White, the Executive Director of the Central Valley Air Quality Coalition and member of the Environmental Justice Advisory Committee. Thank you to all of the presenters and for the opportunity to comment again today. On the process piece, I wanted to encourage CARB staff to consider allowing comments and questions after major topic areas and or to separate these topics out into separate workshops. It's once again felt like quite a marathon to wade through a lot of weighty topics that would be that we could have more robust dialogue if there was opportunity for interaction with each of them. Perhaps we just use the terms differently, but when I hear the term workshop, I think we're doing work together, which requires dialogue. And frankly, this has felt a bit more like a cram session of a series of really long lectures that I get to ask questions or offer my own speech at the end. And I appreciate that at the EJAC, we hopefully will be able to dive deeper and more into these conversations and also want the public to be able to have that same opportunity. You know, this 4-hour chunk is a really long chunk of time, and I appreciate that there's a break built in now, and life is also happening in the background. I need to leave in a few minutes to pick up one of my kids from school. So I'm going to do my best to move through my comments and hopefully also not speak too fast. I particularly appreciate the presentation from Jay with Leadership Council for speaking to racial, environmental, and climate justice implications of dairy digesters and biogas, and particularly the impacts in the San Joaquin Valley where CVAC works. Biogas, dairy confined animal feeding operations or mega dairies are simply not sustainable as they currently exist in the San Joaquin Valley. And as Jay spoke to, we must think about root causes and long-term justice-oriented solutions and investments. Dairy CAFOs produce harmful air pollution and greenhouse gas emissions, including methane. And according to staff slides presented earlier, 45% of total estimated methane emissions are attributable to dairies. Dairy CAFOs are also the leading source of volatile organic compounds and ammonia in the San Joaquin Valley, which contributes to harmful ozone and fine particulate matter, or PM2.5. For those who don't know our notorious reputation in the San Joaquin Valley, we are the most polluted air basin in the United States for PM2.5 and one of the most polluted for ozone. Our plan to meet the 1997 standard for PM2.5 just failed. So we are clearly well over our air pollution budget in the San Joaquin Valley, and we don't have room for short-term band-aids, especially in the face of accelerating climate impacts like wildfires. Dairies and other confined animal feeding operations produce the majority of ammonia emissions in the valley, and our air basin has the largest abundance of ammonia in the world. Ammonia is a toxic gas and reacts to form ammonium nitrate, contributes to PM2.5, and is a criteria air pollutant, precursor to ozone formation, and mixes with emissions from other sources like trucks, tractors, and cars to form half of the valley's fine particle pollution. As Kevin Hamilton just spoke to, there are many other unaddressed pollution streams affiliated with these operations. Both the production and the use of biogas causes pollution, and it is not a sustainable solution. The easiest way to reduce these emissions is to decrease the activities causing the emissions, or at the very least, to not subsidize or support in policies furthering their continuation. CARB should stop over-relying on incentives and technologies and remove biogas from the low carbon fuel standard from dairy CAFOs as part of a just transition and for the health and quality of life and of people in the valley, especially communities that live near these operations that are bearing cumulative impacts from other neighboring pollution sources. CARB and other agencies should focus on achieving an equitable zero emission transportation system and electric grid, which will eliminate greenhouse gases and air pollutants. CARB must also enforce strong mandatory measures that provide direct emission reductions. Regarding biomass, which was also briefly touched on, and I don't feel that I can fully substantively respond to now, but do want to also name this as a false solution. The industrialized biomass plants in the valley that combust woody waste and other materials have only worsened our air pollution and climate challenges. They emit greenhouse gases as well as harmful air pollutants, especially fine particulate matter and NOx, which is again an ozone precursor, which our air basin cannot afford state policies that prop up these unsustainable practices that are ultimately worsening our air and climate pollution problems. These pollutants contribute to numerous adverse health impacts like heart disease, stroke, asthma, early death, particularly in environmental justice neighborhoods where many of these facilities are located. And industrial biomass plants increase overall CO2 emissions without significant energy production and at an exorbitant cost. CARB should be focusing on non-combustion uses for biomass, such as composting and soil incorporation. And regarding some of the previous comments about quote unquote clean next generation industrialized biomass plants, I would like to see the evidence that these strategies don't cause more pollution and worsen conditions in environmental justice communities. This is very much related back to conversations about carbon capture and storage technologies that are unproven and in fact likely increase emissions. Instead of the San Joaquin Valley being positioned as a sacrifice zone where we test out these experimental technologies, we as a region can be a place of innovation and deep investments in resilience, and that is where I would encourage CARB to focus. Thank you for the opportunity to comment.
Thank you, Catherine. We have 2 additional members of the Environmental Justice Advisory Committee and approximately 9 minutes left for this portion. So Paulina Torres is next, and after Paulina will be Georgette.
Thank you, Trish. I know we don't have that much time, so I'm going to try and keep my comments brief. Paulina Torres here, attorney at the Center on Race, Poverty, and the Environment and co-chair of the Environmental Justice Advisory Committee. Quickly want to just echo Dr. Grupa-White's comments about diving deeper into these topics and allowing the public to share more in this space. But on substance, just really appreciate today's discussion and particularly applaud Jay from Leadership Council's presentation on biogas from dairy digesters, and echo Kevin's comment, multiple comments about or reinforcing the idea that we need to approach this as a full system issue. I think we heard from a lot of folks today, and I think to start, there is a consensus here, right, that we need to reduce short-lived climate pollutants. But where we diverge is on how do we address this, and how do we address this issue? And like Jay said, we need to address the root cause. And I think, again, where we diverge, and from where I'm sitting, is which communities, like we as a state, as a society, which communities are we deciding will bear the brunt of the consequences from these false climate solutions? Are we willing to leave the communities worse off or sacrifice the health of these communities in the name of these quote unquote cleaner alternatives? Which brings me to my first and foremost point that EJ communities, particularly the ones with dairies in our communities, are tired of agencies branding biogas as clean and zero carbon, right? I think Jay highlighted this. Pipelines, infrastructure, truck emissions, enteric emissions, it's not clean, it's not zero carbon. And this greenwashing is so problematic for many reasons, and I think in and of itself an environmental justice issue. But not to belabor the point, the production of biomethane from manure to energy projects continues to harm our already disproportionately impacted communities, particularly in the valley, and ultimately perpetuates the expansion of our current harmful agricultural practices while simultaneously increasing fossil fuel infrastructure by entrenching these CAFOs with pipelines for the gas that's produced. And I think at this point, I'm just repeating Jay's comments, but just want to emphasize that I really look forward to working with CARB and other and the sister agencies and my fellow EJAC members to really prioritize direct methane and co-pollutant reductions as we develop our scoping plan priorities. And I will leave my comments there. Thank you all for your time.
Thank you. Now I will unmute Georgette Gomez. You should be able to start your comment.
Thank you, and thank you everyone for this very in-depth multiple hours of presentations. And I do want to echo Catherine's remarks about perhaps adjusting future workshops to really engage as topics get introduced, because it's a lot to take in, and it's really hard to try to capture my reactions to it several hours later. So that perhaps changing that would really benefit the participation on how we move forward. And I just really wanted to uplift the presentation that Jay gave and really centered on communities in terms of how we address the future plan to address the climate crisis. And I think it's really, really critical that as we're exploring and updating solutions and how we're going to be reducing greenhouse gases, that we keep the communities in front and centered. And I think Jay did that in terms of sharing some of the real concerns that these methods have in the communities that the organization that she was representing has. So perhaps that's my question to staff in terms of, because I don't just want to make a statement. I think Paulina and Catherine and everybody else representing EJAC has really stated the major concerns that we have overall, but I just want to hear from staff, what are the takeaways, or how are we going to be incorporating some of these real concerns that currently our communities are facing with these technologies, and to continue perpetuating the potential reduction of greenhouse gases with these technologies that are currently impacting EJ communities.
Hi, Georgette. Thank you so much for the question. And actually, it was one of the things I was hoping to kind of jump in here and talk about after you finished your comments. So I think you know, and some of the other EJ Advisory Committee members know, and the public does as well, that we have been soliciting feedback on the scenario modeling assumptions that we need to do for the scoping plan. And we highlighted those at the beginning of the workshop too, to just kind of ground everybody in what we're looking for from you all, which and some of those questions are around whether or not we see a future for RNG in California under its carbon neutrality scenarios, what the timing is for decarbonizing California as part of carbon neutrality, and whether we should be looking at utilization of strategies that involve waste biomass and biogas, and getting that information from you all, from the public, I think is crucial for us to be able to then model what the energy systems could look like, and the emissions and the potential benefits and impacts of those energy systems as part of the scoping plan modeling process. And so look forward to being able to take that feedback from the EJ Advisory Committee and incorporate into the modeling, and then provide those results for discussion and for additional public input later this year and early next year.
Thank you, Matthew. Just lastly, I just think somehow I'm starting to see this pattern. I think this is workshop, I don't know if it's workshop number 2 or number 3 for me, being that I'm a recent EJAC member. But geography in the different technologies that have been presented, geography, place making impacts are not part of the methodology. And I don't know if, and what I mean is, I mean, from an EJ voice, a lot of the work that we're trying to do is trying to improve, minimize and improve the quality of life of people that are living in these communities that tend to have the burden of the greater societal existence, right? And they're very narrow communities. It's not all over. So there are certain communities that tend to get the impacts because of not really centering in the analysis, the geography. So I'm hoping that as we're evolving the methodology, that we do incorporate geography into these analyses, because then we're not doing our job. And if this administration is serious about addressing the climate crisis, but more importantly, addressing environmental justice, that is very, very critical to incorporate. And so far, I had not seen it. It hasn't been part of the methodology that I've seen in different technologies that have been discussed. And I see even here today that it's not part of it as well. So hopefully I'm wrong. It's there, I just missed it, but I think that's really critical.
Yeah, I appreciate the feedback, and maybe what I'll do is just highlight really quickly, you know, and Jeff mentioned this earlier in the slide decks as part of the day, that, you know, what we're hoping to get feedback on is kind of the broader policies around SLCP reductions. You know, how should we think about the magnitude of reductions that we need out of the sector between now, 2030, 2035, 2045, et cetera. We wanted to give you and the public an update on what we're seeing. And once we start to kind of dig into, okay, what is the kind of magnitude of reductions that we should be expecting out of the sector, we can talk about what are the tools. And that's some of the information that you got today with respect to the dairy digesters, alternative manure management projects, organic waste diversion composting facilities. And, you know, as part of the scoping plan, we'll highlight what are some of those technology solutions to get us to our reduction goals. And after the scoping plan comes implementation. And so what you heard from a lot of the existing agencies today who are implementing recommendations and strategies that came out of previous scoping plan efforts is that some of those, that implementation of some of those projects and some of those ideas is looking at or needs to look at how it affects local conditions, community impacts and benefits. And so, you know, there is kind of this, you know, circular kind of feedback loop of designing the policies, identifying the right actions we should take towards those policies, and then looking at the implementation of those projects and seeing how they can be designed in a way that really helps to benefit communities or avoid any adverse impacts. And so some of those presentations today got into that with respect to the programs that the agencies are running.
Yeah, no, I appreciate that. And I'll stop here. I promise I won't say anything else, but I just do think that, and I appreciate kind of like the walking me through procedure. But I think one thing that is concerning of what I heard right now, Matthew, is the fact that the outcome will deter, like the process. We set the methodology, we set the policies, and let's hope and pray that at the end of the day, the communities that are already overburdened will get a positive benefit. That is from a person that is participating in this process to uplift EJ and truly bring solutions and to these communities that are, you know, historically been overburdened for decades. To hope for the best at the end of the day doesn't really settle very well. So hopefully we can change that dynamic and really put that in front as we move forward, because if that is the intention of this whole process, it's going to be a problem. I'll just leave it at that. Thank you.
Yeah, sure. I know that that is not the intention of this whole process, and rather the intention is also to really solicit feedback from yourself and from others about, you know, these strategies that are helping to reduce greenhouse gas emissions and kind of what the other benefits of those strategies and/or impacts could be. I've got a keen watch on the time here, and so I recognize that we are already about 5-6 minutes over our scheduled end time. what I want to do is obviously make time for public comments, and so we've talked to the CARB staff in the background here. We're going to keep going to 1:30, and appreciate folks' flexibility on the timing. We're going to start working through comments. I think as of right now, we have 12 hands raised if I'm looking at the list right, so we may not get through everybody, but I just wanted to put a flag in. We're going to go a little bit long here so we can hear from the public at large, and hopefully folks can keep their comments to a minimum in terms of timing. And if you have comments that have been stated by another speaker and you want to cede some time to someone else in the for public comment, we'd appreciate it. So with that, Jordan, do you want to go ahead and call on the first name here?
Sure, thanks, Matt. So we have the next three will be Jennifer Bingham, Maddie Munson, and Haley Fernandez. So Jennifer, go ahead and unmute yourself and you can begin.
All right, thank you. This is Jennifer Bingham with Dairy Cares, and I'll keep my comments just focused on, I want to clarify that dairy digesters are some of the best investments that the state is currently making in its fight against climate change. There was a comment earlier that the investments weren't paying good dividends, but that really couldn't be further from the truth. The dairy digester program is by far the state's most cost-effective program in its climate investment portfolio, achieving 1 ton of reduction for every $9 invested by the state. That's really an incredible return on investment that the state's not going to be able to achieve in other important program areas like transportation or community solar. So also wanted to make a note that the climate investment report shows that while receiving just 2.1% of the funds implemented to date, the dairy digester program is achieving 29% of the total GHG reductions. So just want to make a note that's a tremendous return on investment. We should continue to support our dairy families in these important efforts. Thank you.
Thank you, Jennifer. The next commenter will be Maddie Munson. Maddie, go ahead and unmute yourself. Maddie, you're unmuted, but we can't hear you. Go ahead and unmute yourself one more time. All right, we're going to come back to Maddie. Next will be Haley Fernandez. Haley, go ahead.
Hi, my name is Haley Fernandez, and my family owns and operates a third-generation dairy farm in Tulare County. I just want to give a little bit of pretext. What started as a few cows grazing along the side of the road in the early 1900s has now grown to a large-scale operation, milking a couple thousand cows. Hearing our dairy lumped into the label of factory farm is frankly frustrating and unfair because of what those on the outside may not understand is that we are still a family-owned and operated operation. We have just grown to adjust with the cost of operating and the cost of providing for 3 owner families, which includes my dad and my 2 uncles. In addition, we provide jobs both directly on the dairy and indirectly at local milk processing facilities. Finally, I would like to highlight the efforts that our dairy has made to be environmentally friendly and sustainable to reach the next generation. In the last 5 years, we've constructed a 1 megawatt solar system that net meters our electricity usage and an anaerobic methane digester. In addition, many of our acres of farmland have been converted to regenerative practices. I urge you to engage in dialogue with farmers first before making assumptions and find ways to work together and coexist. Thank you for the time.
Thank you, Haley. All right, Maddie Munson, we're going to come back to you. Go ahead and unmute yourself and let's try this again. Maddie, looks like the audio is still not working there. Sorry about that. All right, we're going to move to our next 3, Julia Levin, Veronica Pardo, and Sarah Deslaurier. So Julia, go ahead and begin.
Hi, this is Julia Levin with the Bioenergy Association of California. I wanted to go back to a couple of the comments made in the presentations. The first is a question that the Air Board asked about what the highest and best use of renewable natural gas or biomethane is. And I agree with the comment that Sam Wade made in his presentation that that's going to be very different when we're looking at short-term, medium-term, and long-term. It's probably going to be different answers. Short-term, I don't think there's any question that the highest and best use is to get rid of diesel, replace it with renewable natural gas or renewable hydrogen. But longer-term, it may be a very different answer. It may be reliability in the electricity sector, or it may be for use in hard to electrify end uses. We just don't know yet because it depends on what happens with other technology development. In addition to the difference between short, medium, and long term, though, it also really depends on the location. For RNG projects, it depends on whether they're close to a pipeline, a highway, a power line, whether it's in a rural forested community that's facing public safety power shutoffs or other power shutoffs on a regular basis. It just will depend a lot on location. So I don't think it's going to be one size fits all, and we should stop trying to answer the question as though it will be one size fits all. I also want to underscore the comment that Denny Zane made about the urgent need for more funding in this area to get rid of diesel and to reduce short-lived climate pollutants. As several speakers have commented, the state's investments in dairy digesters and diverted organic waste have been by far the most effective investments and the most cost-effective investments. And we need to continue and significantly increase them to meet our SLCP reduction goals. 2 other points for CalRecycle. In terms of the digestible waste, we really should be incentivizing projects that do both anaerobic digestion and compost. The state of Oregon considered 147 different studies, the Oregon Department of Environment, and found conclusively that the projects that do both bioenergy and compost provide 3.5 times greater carbon reductions than compost alone. So with very limited dollars at this point, we should be incentivizing projects that do both and maximizing the benefits. We also have to address cellulosic waste going to landfills. The vast majority of our organic waste that has to be diverted by 2025 is actually cellulosic waste, meaning it's not suitable for anaerobic digestion or compost. We need to move forward with non-combustion conversion technologies like gasification and pyrolysis to deal with the rest of our organic waste. The last point I wanted to make has to do with Stacy Heaton's comments this morning from the rural counties representatives. I think we do need to consider the needs of local communities. That has been underscored by many members of the EJAC and others. But we also need to consider the needs of our forested communities. And no one has really been representing them today except for Stacy. They have very different needs. They are also economically disadvantaged. They are the most vulnerable to wildfires and power shutoffs. And I really urge the Air Board and other agencies to bring out the voices of our rural forested communities much more. They are important too to these discussions. Thank you.
Thank you, Julia. All right, we currently have 12 hands raised. So next would be Veronica Pardo.
Hi, thank you. Veronica Pardo, Resource Recovery Coalition of California. Just a few comments I want to make regarding the lack of infrastructure that California has to manage the volume of organic waste we generate, with less than 6 million tons diverted via compost and anaerobic digestion in 2015. CalRecycle estimates that approximately 108 new or expanded compost facilities and 61 anaerobic digestion facilities are needed to meet our organic waste diversion goals. And with any mitigation effort, there is no perfect solution, and both compost and anaerobic digestion pose their own benefits and barriers. Ultimately, critical investments are required so that these facilities can successfully meet the most stringent air and water quality standards, while also managing the volume and feedstocks necessary to achieve our goals. Additionally, the organic waste products they produce must have viable markets to sustain the diversion system. It is also imperative that we advance organic waste management goals with an environmental justice framework to not further burden our most impacted communities with development that could threaten air quality. It's critical that we develop local organic waste management systems and infrastructure that ultimately reduce VMT and guarantee communities remain responsible for their own waste generated. This has the added benefit of bringing green jobs to the local community with both diversion and food recovery infrastructure, as well as the production of renewable energy, composts, etc., to support the local economy and California's overall GHG reduction goals. We must develop a long-term strategy to efficiently divert organic waste from the landfill that addresses the cost and regional regulatory limitations of organic management, including a strategy for biogas and compost use. The strategy should include goals for local organic waste management development that supports a circular economy framework. In other words, we need to bolster local resilience and put organic waste to beneficial use within the local community. And we support a number of solutions, including a coordinated cross-agency strategy to bolster our organic waste diversion system. long-term statewide funding to support diversion programs, including an appropriate landfill tip fee increase, development of coordinated and streamlined permitting for new or expanded facilities, regulatory certainty that investments will not become stranded assets in the future, especially as it pertains to renewable biogas use, robust state procurement of organic waste products to drive organic management, development, and markets, including RNG utilization, and tax credits and incentives to encourage more private investment for infrastructure, as well as honor the early investment of private entities who supported state efforts for early compliance with recycling mandates. Thank you.
Thank you. Next, we have Sarah Deslauriers. Sarah, go ahead.
Hi, thank you. My name is Sarah Deslauriers. I'm with the California Association of Sanitation Agencies, representing the wastewater treatment sector's perspectives on climate change. I just want to thank you for the extra time to be able to provide these comments. I'll make it short, so we'll deliver written comment as follow-up to these comments I'm saying today. But just wanted to note really quickly in the CalRecycle presentation that there was a slide that showed the needed capacity related to the anaerobic digestion. It was showing very low relative to the recent State Water Resources Control Board report that was released on co-digestion capacity related to POTWs across the state, which showed that they actually, depending on their operation, could take all of the divertible food waste that is going to landfills at this point in time. And of course, then process that into two products, biosolids, which are federally and meet federal and state regulations for their beneficial use and show that they can achieve carbon sequestration among other benefits to the soil and crops, and have been acknowledged as such in the soil enrichment protocol that the Climate Action Reserve has put out in last September. So we'd like to see that same acknowledgement in the Healthy Soils Initiative, Forest Carbon Plan, and Natural and Working Implementation Plan, or Natural and Working Lands Implementation Plan, because we know we can help accomplish recovering or reclaiming soils and increasing carbon sequestration. In addition, there's the biogas product as well that has been mentioned in the CPUC presentation, which captured a lot of the opportunities there for the wastewater sector, and we do support Senate Bill 1440 and helping utilities providing biogas and through pipeline injection, but also the low carbon fuel standard is another, I guess, credit that we'd like to take into consideration as well, and thinking about using that biogas as a renewable transportation fuel, which not only can accomplish that, up to 90% reduction in NOx in vehicles that are available right now and infrastructure that's available, but also serve as a resilient transportation or vehicle for the essential public service that we provide. So we have resilient, I guess, fleets that can actually respond to critical and emergency situations that have been presented by different natural hazards as of late. So with that, I just wanted to wrap up there. Really appreciate your presentations and look forward to working with you, and we'll be submitting our comments. Thank you.
Thank you, Sarah. Our next three are David Rothbart, Rebecca Spector, and Shane Petkowitz. So David, let's start with you. Go ahead and unmute yourself.
Thank you. This is David Rothbart, and I'm representing the Southern California Alliance of Publicly Owned Treatment Works. And essentially, I just want to focus on the short-lived climate pollutants and how SB 1383 needs to acknowledge some regulations. Essentially, in California, we have something called new source review, and when you permit new facilities, you have to deal with new emission sources. So if you take the food waste out of landfills and go to a compost facility, you're going to need to go through new source review. And this is something that's a major barrier. I do operate compost facilities, wastewater treatment plants, and I do know there are not enough credits available in the new source review program to allow the expansion of compost as needed for 1383. And as Sarah just talked about, as far as diverting the food waste to wastewater treatment plants, that infrastructure exists without building new facilities. That makes sense, but new source review limits what you could build for a stationary source. So the only way you're really going to take advantage of the methane reductions you want for short-lived climate pollutants is to put it into wastewater treatment plants and allow that resulting renewable fuel to be used in transportation fuels. And I do want to emphasize that in the South Coast and San Joaquin, they need reductions now. They have to get to attainment now. They can't wait till 2035 or 2045 to electrify. So I strongly recommend that CARB work with air districts, CalRecycle, and find a way to work together to find a solution to clean the air as soon as possible. Thank you.
Thank you, David. Next, we'll hear from Rebecca Spector. Rebecca, go ahead.
Hi, Rebecca Spector. I'm with the Center for Food Safety. Center for Food Safety supports subsidies to farmers to help them transition to practices that reduce environmental impacts and reduce the impacts of climate change, but this does not include methane digesters, which produce biogas, which is not a clean energy. We encourage greater diversification of funds towards practices that reduce methane and provide significant co-benefits, including reduced air and water pollution and increased carbon sequestration. This would include an increased funding for AMP and helping farmers transition to other production practices, which may include greater reductions in herd size. We also support a greater focus on increased funding for the Healthy Soils Program, which helps farmers transition to other production practices that sequester carbon. If funds for these programs are increased and they match or exceed the funds that have gone toward digester, we'd see significantly greater reductions from those programs and practices. If these incentives are not adequate for reaching the reduction goals of the state, then regulations will be necessary. And as other presenters today have shown, it's regulation of other industries such as oil and gas and landfills that has resulted in the greatest reductions. Our views are not ideological. They are based on science and are forward-thinking solutions. These solutions encourage vibrant agricultural economies, support family farmers, employ more people, and utilize practices that provide environmental co-benefits and reduce methane emissions. Thank you.
Thank you. Next, we'll hear from Shane Petkowitz. Shane, go ahead.
Yes, hello, my name is Shane Petkowitz, and I'm calling from Energia. I really want to thank CARB for the opportunity to present to the panel on the short-lived climate pollutants and for giving us the opportunity to comment. I really want to focus my comment on the methane emissions associated with organics in landfills. I think Anthony Alexiadis gave a presentation or slide that indicated that 21% of methane emissions in the state of California are attributed to landfills. I think actually recent data with improvements in monitoring techniques is finding that methane emissions are actually significantly higher than that. And the situation is actually more dire than anticipated. A recent study by NASA JPL in 2019 indicated that landfills could be attributed to up to 41% of methane emissions for the state. And my question really to CARB is what steps are they taking to be able to update its current life cycle assessments and assumptions for methane capture at landfills, and particularly as part of its Tier 1 calculators and LCFS programs. I think the current 75% assumption is outdated, and it should benefit from the improved data to improve the current assumptions of what methane landfill capture. And I think doing so actually has a tremendous opportunity for helping other organizations, including CalRecycle, to help SB 1383 meet its goals. An improved or lowered CI score for diverting organics from landfill can enable the infrastructure and investment that's required to divert organics from landfill away from MSW. And this can be done through retrofits of wastewater treatment plants or building of anaerobic digesters. So I think there's a lot of benefits to be able to update this using data that's already in place. And I look forward to having this conversation further.
Thank you, Shane. Yeah, I appreciate it. I heard my kind of a prompt for us there. So I just want to encourage you to submit written comments too. Obviously very familiar with the JPL NASA work, but understanding, and this is one of the questions that we had put out there as part of this workshop. What are the technology solutions? What should we look at from the perspective of methane capture rates that based off what we currently assume? I'll have to answer some of those questions in the presentation. So welcome your feedback, welcome your written comments. All right, Jordan.
Thanks. Next three will be Ryan Kenny, Brent Newell, and Brian Nowicki. So Ryan Kenny, go ahead. And Ryan, you'll have to unmute yourself as well.
Thank you. Good afternoon. My name is Ryan Kenny with Clean Energy.
It's been a great discussion this morning. Thanks for everyone for their time. I want to point out an assumption that I want to rectify is in that heavy-duty zero-emission vehicles are nearly or are commercially ready. And I want to encourage everyone on this who's participating today and listening, and especially the EJAC members, to get a hold of the South Coast Air Quality Management District letter dated in August. And I'm sure CARB staff has it if you want to ask for it. That letter provides 9 pages of empirical evidence of why they support zero and near zero emission vehicles operating on renewable fuel, because heavy duty ZEVs are not commercially ready now or not expected to be ready for years from now. If you look at the executive order requiring electrification, the executive order requires heavy duty ZEVs to be in place by the year 2045, and that's even where feasible. That's a qualifier. So heavy duty ZEVs are not close to being ready, and we've got a carbon negative or a low carbon fuel and renewable natural gas that can be used now immediately to displace diesel. Both Sam Wade and Julia Levin mentioned the near term highest and best use. And if we're looking to get rid of diesel off the road and really reach those short-lived climate pollutant goals, this is the way to go. This is the cleanest fuel you can buy and use on trucks to displace diesel now. And Sam Wade mentioned in his presentation that 98% of natural gas used in transportation is renewable natural gas, and that's no accident. That's because the LCFS is driving economic adoption and making it feasible economically and cost effectively to adopt low NOx trucks with renewable fuel. My company alone has 165 renewable natural gas fueling stations in California, and it's no accident that it's all RNG. It's because of the LCFS. So you've got the LCFS as the driver, you've got the near-term solution to displace diesel, you have low carbon to carbon negative fuel to displace diesel, and that is a solution right now to really help out the disadvantaged communities, especially that are choking on diesel exhaust and carbon emissions and black carbon. So again, check out that South Coast AQMD letter if you're interested in learning about the readiness of heavy-duty ZEVs, which are not commercially ready anytime soon. And thank you for your time today.
Thank you. Next, we have Brent Newell. Brent, go ahead and unmute yourself and begin.
Hello, I'm Brent Newell with the Public Justice Food Project. I want to start by supporting the comments made by Jay Jordan with Leadership Council. And I want to make 2 points this afternoon. First, building off of Catherine Garuba's comments about fine particulate matter in the San Joaquin Valley, that air pollution health crisis, and the role that ammonia plays in that crisis, it's imperative that CARB recognizes that factory farm gas, this anaerobic digester production of biomethane, leads to an increase in ammonia emissions in this air basin. That's what the science says. Let's follow science. It's not ideology. You shouldn't adopt a methane reduction strategy that increases a precursor of a criteria pollutant in the most PM 2.5 polluted air basin in the country. My second point is that CARB's analysis of methane reductions from manure management that were presented here today improperly includes reductions that are utilized by pollution trading schemes. CARB's estimates of emission reductions from dairy digester relies on projects that are funded through both the California Climate Investments Program, that is the Dairy Digester Research and Development Program, and through pollution trading schemes. Such schemes allow polluters to buy reductions attributed to digester products, and then those fuel producers keep polluting in the case of the low carbon fuel standard. What CARB should do is amend its emission reductions estimates for any digester that is selling offsets, low carbon fuel standard credits, reductions that are attributed to the Aliso Canyon mitigation program, or any other pollution trading scheme. You should exclude these pollution trading reductions from your reduction estimates here because they're not additional. They are being used to demonstrate compliance with another program, with the low carbon fuel standard. You can't claim compliance with 1383 and reductions that are required under the low carbon fuel standard at the same time with the same reductions. These reductions from dairy digesters that are selling low carbon fuel standard credits into that system aren't really reducing greenhouse gas pollutions in the overall aggregate. They're allowing more emissions from fossil fuel combustion in vehicles. Thus, that CO2 has a long lifetime in the atmosphere. There should be direct reductions from dairy sources, avoiding methane generation in the first instance. And the food project supports policies that support regenerative, pasture-based farmers who are part of the climate solution. Thank you very much.
Thank you, Brent. So I'm just going to jump in here really quickly and say, Brian Nowicki, we flagged you as the last of the speakers here based on timing. And so, Brian, if you could close us out, and then we're going to have just a couple of minutes of closing statements for the day.
Thank you very much, Brian Nowicki, Center for Biological Diversity. I will be extremely brief given the time. Just want to give my great thanks to Jay, Catherine, Kevin, the others from the EJAC who gave their raised the various points. I'm not going to be able to add on to any of those. Only to say the Center for Biological Diversity, very pleased to hear those critical points. I heard some themes today that I was very heartened to hear, and that is it's time to look at systems and the full scale of what the proposed approaches are, as well as a particular attention to geographic externalization of impacts. This is important to all sources, but is going to certainly be important when we look at bioenergy and the forest and fire issues that we've discussed today. Obviously, I'll be putting these comments into writing, but thank you again to everyone for this workshop.
Thank you, Brian. Actually, great points. I also wanted to just reiterate a big thanks to our panelists, to the members of the EJ Advisory Committee, to Jay, and to others that have given their presentations today and their thoughts. And then also thank you to the members of the public who have given your comments as well. So I am going to ask that Jeff close us out here. I think he's got a handful of slides left. Jeff, as quickly but clearly as possible, if you could run us through the last couple of slides. Thanks.
Yeah, absolutely. Thanks, Matt. So we're just going to take these couple of slides to iterate over what has been mentioned already, largely for what we're looking for in terms of feedback. You've seen that the state has made some progress in reducing our methane emissions, especially in dairy and livestock sector, and has made some progress towards reducing black carbon emissions. Moving forward, we need to evaluate additional emission reduction measures and targets that can be achieved within these sectors, especially in relation to carbon neutrality. Next slide, please. And to highlight some other key takeaways, SLCPs play a pretty important role in the state's overall emission inventory. Further reducing these short-lived climate pollutants will be necessary for meeting carbon neutrality goals. And there's this fundamental interconnection, which has been hit on by many panelists and many comments, between short-lived climate pollutant reduction strategies and how those strategies may play out and impact emission reductions for other sectors. And so CARB intends to evaluate many pathways as part of our carbon neutrality framework and modeling that will go on over the next several months. And it's possible that given the current trajectory, deeper SLCP reductions are likely needed prior to 2030 to achieve carbon neutrality. And we look forward to feedback on additional evaluation that needs to occur across this area. Next slide, please. So the scoping plan timeframe, just a reminder that the scoping plan is slated to continue through 2022. There will be numerous additional workshops. A draft plan is expected to be out sometime next year, and the final plan will be due at the end of the year. Next slide. And we definitely don't have time to get to everyone's oral comment, and we do strongly encourage sending written comments. The deadline for that is September 22nd. So please get us your written comments before then. If you have found this presentation already, you can submit your written comments through the workshop website. And there's additional resources that are available on our scoping plan website, including the past workshops. And there are also future announcements. So please sign up for those listservs if you are curious. And that is all for the day. Thank you so much for hanging out with us for this marathon session.
Thank you, everybody, and have a good afternoon.